Okay.
Okay, so let's get going. Welcome everybody. My name is Neil Leach. I'm one of the initiators of the Digital Futures project along with Philip Yuan. It's now in its 10th year, and following on from Digital Futures World, the large online global event we had over the summer, we are continuing with a series of presentations by both the instructors and those and by the students themselves. Today we have a session on computational design that is being a series of presentations that are being given by the instructors from Digital Futures World. We're going to start, we have a list which you've probably seen online. We're going to start slightly out of order in that Xinyu is in Australia right now. In Australia, it's just gone midnight. Here in California, it's 7 o'clock in the morning and 10 o'clock on the East Coast and 10 o'clock in China. So we'll start with Xinyu just so that she's not up all night. Xinyu was working with Elisa Andrashek, teaching a workshop in Digital Futures World. And she is based at RMIT, Royal Melbourne Institute of Technology, the most progressive school, I would say, in Australia. So welcome, Xinyu. Are you able to share your screen?
I'll share my screen now.
Yeah. Okay. Thanks, Xinyu.
Can everyone see my screen?
Yes.
So, hello everyone. This is Workshop Complexity. Before I start, I'd like to thank you all for joining this section and also friends on YouTube and Bilibili today. Also, thanks to Digital Future for this exciting workshop during this difficult time. My name is Hu Xingyu. I'll be representing Complexity team to give a presentation today. So this workshop in Digital Future was led by Professor Alessio Erioli, PhD candidate Joshua Lai, Maris Barbarolos, and Wu Xingyu, which is me, a research assistant, also a year 2 student in architecture. So we are all from the research team Complexity Lab in RMIT University. This workshop is also a study based on this large research project. Complexity workshop aimed to adjust design for high-density cities based on principle of complexity. So propose a future urban plan based on the idea of automated construction, adaptable algorithm, and showing the relationship between new technology and architecture. So today I'll be mainly talk about the concept and workflow in this workshop tonight. And now let's see the Oasis City project from this workshop. So this video shows the final result of what this workshop trying to achieve. Sorry. So at the first stage of this workshop, students search through the image of the Mars dune from NASA. The 2D Mars dune image shows the potential of a site that will have various detail and countless changes. We aim to capture the form of Mars as a fundamental basis to express the quite extreme landscape condition in order to emphasize the adaptability of the complexity concept. The idea behind it is we are looking at when the Earth starts suffering from the enormous pressure of high growth population. People need to find a way to work with high density architecture, and also how it may adapt to the landscape in an extreme condition when there is shortage of land resources. So for example, let's say the central desert of Australia, or even Mars colonization we are talking about. So in order to capture the character of Mars dune, we use the color and shadow data to generate a map that is around 3 square kilometer to 10 square kilometer with a 300 maximum height. Test with different scale to capture the richness of the hill and the slope, also the various changes of the site. So as mentioned before, with this testing of different site model, we are using form of it to emphasize the adaptability of our future urban proposal. Various conditions within the field, within this field, offer opportunities for diverse urban program. So also with the site analysis of the previous site, it demonstrates different features that could ground the project and assign the program accordingly, provide a further guidance to human or non-human space adaptation. It also gives the idea of how we could construct the agent behavior later to fully capture the richness of the landscape. So then we run the multi-agents through and crowd the landscape to test different potential urbanism. This shows some of the process of the agent study. So the system of the flux give opportunity to build up a city that is based on similar human behavior. In other words, we are proposing a more divergent and organic urban that is based on the citizen activity with the site. With different application of the attractor and void, we can test agents through the site in order to capture the richness, different resolution, and interesting moment of the Martian landscape. So with different experimentation, looking at the gathering and the void of each testing, the proposal of future city that is purely based on different patterns of complex organization produced by this algorithm. It is fascinating for contemplating pattern for a self-organized future city. So looking more in depth of the algorithm to analyze different feature and the density of the urban to further work with the organization of the city plan and generate a function based on its result. So then we transform the pure data spatial condition using voxelization as a tool, which gives opportunity to rationalize its circulation and the site data in a three-dimensional or vertical condition. Those are the fundamental idea of our urban proposal generation. So in complex city workshop, we are focusing on the organization of the human and non-human fabric to assign function into different layers. The human and non-human fabrics provide a new vision into our future urban design search. Zooming in with more detail mapping, it shows the potential to be more detailed with applying the urban fabrics later. Consider the voxel in our case as a pure data carrier. The analysis gives a guidance to map the components, a single spacing, but with the large scale aggregation, it could form as a city. And then I'm going to show the process. So this is how the components could map to the voxelization. And then let's talk about the urban fabrics design, the single spacing that being used. For the urban fabric design, the future we picture is a highly automated society. The prefabrication architecture concept widely used here. So as this diagram illustrated, using the basic and simple discrete input to generate complex urban pattern is our goal here. So use very simple geometry, give it function, and use it to generate different parts of architecture. So from the previous knowledge, the concept have basic geometry, and we design the connection logic to generate those abstract elements with different logic of connection. Extending the part-to-whole relationship, this workshop look at how space may form by the very abstract element from the very beginning and the space it generates. So use that logic, student in this workshop develop some sequence of chunks to test the different connection logic to achieve different spatial quality it creates within the simple input. By the way it connected, one class of components could form extremely dense and look at its function as a machinery space. So with more in-depth study, combining the knowledge from the previous site analysis, students develop a series of chunks to adapt to the environment, such as energy production, human inhabitable space, or public space transitioning. So different flexibility of fabrics creates a very rich and differentiated spatial condition. To consider the function, let's say, for example, the space that are more crystallized are involved with more human behavior, and more solid and dense components could be like in the selected non-human fabrics. So developing from the small aggregation in this theory, testing the multi-components in one similar class in a small aggregation to potentially showing how it may form in a larger scale. With this aggregation testing, the main study of the components are not by the component itself, but the logic of connection. So with those concepts, a single space could be a very, very abstract components, but the space was created by the larger aggregation and also the logic of connection. Looking into the urban fabric that using different connection logic with multi-urban fabric testing and apply it into urban scale. So then it's the urban video. So in conclusion, this project is a combination of the aggregating connection logic and the agent behavior, exploring a new way to consider the future architecture with our vision of new technology. The main workflow that I'm using here is running agent simulation first through the extreme landscape, and then use the voxel as a transition data carrier, transforming the data from agent to temporary spacing, then map the multi-urban fabrics, and it forms a larger scale city. So with that concept, we can think of our further study, even expand like more investigating how big data, artificial intelligence, or automated construction could be our future task. So exploring new fundamental of architecture at increased resolution with super performance. So those render image showing here is from our student in this 7-day days workshop. In this workshop, students are more focusing on design search to search through the best outcome of this workflow. And above is my presentation today. Thank you all for listening.
Thank you, Zhenyu. I should say that maybe to say a few words about Elisa. I should possibly have introduced her as she wasn't able to present today, but Elisa is someone I think that deserves a certain credit for being a real pioneer as a female architect in this particular world. Elisa, a long time ago, 1999, studied in Columbia under Carl Chu, Manuel de Landa. I also taught her a class, although she taught me, but since then, Elisa's been a real pioneer in many ways. She taught in the States for some time, then moved to the UK, taught at the AA and the DRL, Design Research Laboratory, and had some many significant students there, and also went to the then went on to the Bartlett, where she set up Wonderlab. Her name Alice in Wonderland. You can see the connection there, and has now moved to RMIT, where she is teaching alongside one of her former students, Roland Snooks. I should also mention that Gilles Redsin was one of her former students, and I think Alisa has a really significant place in history as a kind of female pioneer, and one who has, I think, set up a series of very interesting labs around the globe. So thank you, Jinyu. That was amazing to see what you managed to produce in 1 week with your students. Actually, very extremely rich, an amazing project. I'm glad we got a chance to see that. Slightly ironic in the sense that I think that nobody lives on Mars yet, and you're proposing a dense city there. And maybe even one could say that we wonder what the future of dense cities is in the age of COVID-19, and whether people will want to live in places like New York City as much as they did in the past. But anyway, that was wonderful to see that. Jinyu, as I mentioned before, is in Australia, where it's gone midnight. I don't think that Jinyu will be able to stay for any questions at the end, but I just want to thank you for showing us, I think, a really remarkable project, and to see the kind of quality of the work that came out of Digital Futures World. I hadn't seen that project before fully, so it's fantastic to see, and congratulations. So let's move on. We've actually got I think 5 presentations today. The next one is going to be Vishu Bhushan. You might know him by his brother, Shajay Bhushan, who set up Zaha Code, the computational research group in the Zaha office, and Vishu is also one of the most significant members of what is now an increasingly important research institute. So, Vishu, over to you.
Hi, yeah. Hello, can you hear me?
Yes.
Are you able to see my screen? Or are you able to see my screen, Neil?
Yes.
Yes.
Yes, we do.
Okay, cool. Thanks for the introduction, Neil. Yeah, I'll be representing the Computation and Design Research Group, Zaha Hadid Architects, at Zaha Hadid Architects, and presenting our research ideology and the things we produced in the workshop. I also teach at the Architectural Computation at the Bartlett. It's an MSc course there, where we explored similar topics like architectural geometry over there as well. First of all, I would like to thank Digital Futures organization for inviting us not only this year, but like renewing this collaboration over the last 4 years, since 2017, when we started with like exploring equilibrium with Philip Bloch, and then subsequently doing our own workshops in 3D printing, wire cutting last year. And this year, as it was moved into online, it was more of a design and play. I'll give a brief introduction about the group, the Computation and Design Research Group at Zaha Hadid Architects. I'm representing also the tutors. There were like 6 or 7 of us who came in at various times during the workshop. So a big thank you to all of those. The code group was started in 2007 by Shajay, Patrick Schumacher, and Niels Fischer. Since then, we have been involved in doing a project-independent research, looking at technologies available for fabrication to create geometries, but whilst at the same time bringing the learnings of these demonstrators onto real architectural projects within the office. And along with that, developing a network with academia, engineers, fabricators, so on and so forth. So our research kind of situates in between what we call design and play. On the design side, we look into things which are valuable for architectural design. And also on the right side, we look at technologies or design technologies will allow for computation to do so. And the amalgamation of these two, or the intersection of these two, is where we situate our computation and as well as design research. We look to continue or learn from the past. So we look into precedents like Gaudi, or even mathematicians like Lionel March, to seek for first principles. and we code to understand those principles. So we write our own tool sets and develop our own custom frameworks. So we understand the first principles of these algorithms and then implement them as a design tool. We share a language of geometry just because it is very visual, and also it is a tool of collaboration between the other disciplines involved in architectural design, like engineers, fabricators, etc. So the workshop, we brought like a couple of strands of research within the group, focused on architectural geometry, habitat, and also bringing a bit of the participatory housing and configurator aspects into the workshop. So what is architectural geometry? It is making visible in shape the structural and fabrication performance. And more so recently, we are trying to embed other performance criteria like environment, sustainability, so on and so forth. This allows you to create tools to explore mathematically different shapes, but at the same time limiting the design space, which are fabrication aware or statics aware. So this is kind of this is a at the Science Museum in London, where it was the geometry is a minimal surface, so it could be built with fabric, but also rationalizing it so that it is easily bendable with in a 2D bent pipes. So these geometries we explore are geometries of physics and have a fabricational rationality to it. And this is not something new. As we said, we look into history to do these kind of things. We are trying to build upon work by Antonio Gaudi, who brought hanging chain models when he was designing Sagrada Familia, or descriptive geometries like ruled surfaces, which he used again in Sagrada Familia, which was later on developed further by Mark Burry. And as you can see, it is coming up in Barcelona. But also other engineer architects like Felix Candela, Frey Otto, who looked into soap bubble form finding and combining, especially getting these kind of static aware and fabrication aware geometries into an early design stage. Although they were all the presidents were like master architects and engineers with computation and methods like force density method or the thrust network analysis, which brings in a combination of statics in combination with geometry. It has become more feasible for designers to visualize and interact with these kind of tools. This combined with concurrent research in developability, ruled surfaces by researchers such as Helmut Pottmann, Axel Killian, and research groups such as Keenan Crane in Carnegie Mellon, or interactive geometry groups in ETH Zurich, allows us to look at these first principles, look at their papers, build up the tool ourselves, and basically augment the designer intelligence with these set of tools. So the geometry explored is much more rational. And then we do these kind of workshops similar to ones we did in Digital Futures last year or previous years to explore certain technological aspects. In this case, it was looking at hot wire cutting, but in some cases, it might be looking at static side of things or energy side of things. So these tools, computational tool sets combined with maturing digital fabrication tools, such as one you see on here, which is for knitting, combined with hot wire cutting and robotic fabrication, is allowing you to quickly do these kind of technology demonstrators over a period of a workshop. This is a workshop in India, almost like 7 to 8 years now. And bringing the same learnings into build projects within the office. This is the Science Museum again in London. Here it's highlighting both the minimal surface, fabric surface, as well as the wire cut, hot wire cut benches. So this one kind of highlighting the use how robot having that tool set within a computational framework allows you to explore these kind of various geometries and create these technological demonstrators. This is Nit Candela in collaboration with Block Research Group and Architecture Extrapolated. This was done to design to fabrication in about 2.5 to 3 months. So the technology is maturing quite fast, and that is allowing us to go take a leap from technology demonstrators to actual large-scale build projects in stadiums, in arena design, like metro stations, offices, residential buildings, so on and so forth. But we believe that the core, these kind of robotic and digital fabrications combined with the geometrical technologies we presented is kind of explored in the second strand of research we have, which is habitat or residential units which adapt to a context, which explore the idea of modular and bespoke and bringing in digital manufacture and fabrication into it. So the idea in the workshop was to explore this kind of kit of part, which is created using the architectural geometrical tools we showed earlier. And this allows, because of the mixture of robotic hot wire cutting, you can get something what is called as modular bespoke. So you have some aspects which are modular, but at the same time bring in customization because hot wire cutting allows for that. And this was some things which students were exploring to kind of create like a pixel module of voxels and then populating them with the kit of path of geometry. So this is like one of the outputs looking at combining how a kit of part can be like a combinatorics exploration of how like kits of 3 to 4 parts can lead to a wide variety of geometry exploration and unit exploration. This combined with something what we call like a smart grid, like how to make a grid on site so you can stack units on one on top of each other. So this was another workflow which we explored in the workshop to try and create a smart grid on which you place the units and then subsequently develop the geometry to place on them. And you can start combining these volume stacks with some metrics such as views or stability in structure, stability in terms of fabrication, feasibility, so on and so forth, which augments already smart grid pixel picking with these kind of rationalities of if it is stable under gravity or if it's stable to build one block at a time, so on and so forth. So this set of tool sets allows you to explore a universe of feasible solutions which are constrained or under parameters such as views, such as structural stability, a number of unit mixtures, and then creating a tool set to actually create various options of navigating a given context, such as a terrain or a sloping slide or a tower. So these were some examples. This is actually our project using the same tools. This is a live project which is going to go on. It's in Roatan. These tools can help you to quickly do design computations such as like a modular housing, student housing in Hong Kong, or this kind of temporary housing in London, or create towers using the same logic, try to adapt the same logic to create towers in it. That bring this level of customization which you're able to bring through architectural geometry and integration with robotic fabrication actually brings to an important point which we are exploring currently, is to bring stakeholder participation into the design process. By stakeholder, I mean here end users, such as who's going to live in the apartment, or a developer, or a boutique hotel operator. So all of them are able to contribute or choose. So because of the customization you're able to bring in with geometry and the unit shapes, you can allow the user to actually interact, and actually it's similar to what you call like a seat picker in a flight. Here, the end user is able to pick where he wants the unit to be. So this is like version 1 of the configurator, trying to play the game of how many pixels he or she wants and what kind of unit he or she wants. And so basically collecting a set of choices. So this video is I'm not playing the whole video, it's quite long. I can send the link later if you're interested. So this, like I'll end with like a video of all the works of the different groups in the workshop. There were 36 students. It was they're split into groups of 4, exploring the 3 different aspects which I presented, which was architectural geometry, then creating a smart grid or creating voxel or pixels to choose from, which are tested against stability of structure or stability of views, access. So these are the different types of strategies the students were bringing. So this one is doing a rigid body physics to see if the units are stable, then a unit view analysis to try to get maximum views to the river, then bringing in some kind of solar analysis and then other algorithms to do the stacking themselves. So this is like 3 modules trying to stack them together, and then exploring how a kit of path, like 5 to 6 kit of path, which are all under the rationality of ruled surfaces, can be stacked together to build the module or the unit themselves. Some of the students also brought in their experience in trust network analysis and graphic statics into the workshop, or in robotic fabrication and hot wire cutting. Some also brought in 3D printing. So it was, I would say, a hackathon for design exploration. And this was some people were exploring vaulted structures. Some were exploring metal and curved crease folding, and then putting all of these into an online configurator where you could the user could actually pick and choose certain aspects. In this one, picking like slabs, what are the structural parameters, like facade. Yeah, so basically giving a choice to the user. So that would be my presentation.
Thanks, Vishu. That was terrific. Wonderful work. I should also, I think, thank the rest other members of the Zaha team. I think there was literally the Zaha Code team. There was a whole team on this, including, of course, Shage. Of course, we are indebted to Zaha herself, who I think, history will look back on what that office has done for architecture, because I don't think that we've ever seen in history an office that's been so progressive and yet so successful. Really remarkable. So I'd also like to extend a vote of thanks to Patrick Schumacher, who has been constantly very supportive of Digital Futures initiative. He is himself a PhD supervisor in Tongji for the Digital Futures PhD program. And also kind of connected with this discussion with Vishu's presentation, behind the scenes, there was a Philippe Bloch, with whom Shage is doing his PhD in ETH Zurich, also involved in Digital Futures. There's Aki Menges, who's in the same institute as Frei Otto and somehow connected in a certain way. And finally, also Mark Burry, who has been working on the Square Familiar and is also involved in Digital Futures. So it's wonderful to kind of have that presentation that brings together both the workshop and this incredible office, plus the other people associated with Digital Futures. That's a tough one to follow. The only person I can think of who can follow it is Satoru. Satoru Sugihara is our next presenter. Satoru, some of you will know from teaching at SIAC over the years. He's now back in Japan. While he was in LA, he was also, he studied, I should say, at UCLA. Then he worked for Morphosis for many years and was responsible for some of the most astonishing integration of computation into the design of that particular office, and now he's, as I say, he's back in Japan. Satoru, are you there?
Sure. Yeah.
Okay, over to you. Thanks, Satoru.
Right. Let me start my share screen. Okay. So, all right. So first of all, yeah, thank you very much for this opportunity. I mean, for tonight, and I mean, right now it's midnight, but tonight, and also the workshop opportunity I had in Digital Futures. So anyway, let me start with I'm kind of self-introduction. So I usually most of the time work with I usually design a facade for other architects. So I'm running right now running a computational design studio in Tokyo called ATLB. And then, okay. So those are the kind of type of work I do. And then a little bit out of the computational technique, more specifically processing code. But anyway, today, first, let me talk about this kind of work, which is not directly connected to the workshop topic, but kind of gradiently kind of connected to the topic of the workshop as a background. And but in most of the work, I have like a two direction to aim at. And first year, as many other like computation designers do, like I try to kind of pursue certain design advancement, but me specifically kind of certain that type of complexity that kind of certain quality I pursue. But at the same time, also construction kind of rationality, especially for like, I mean, for me to design facade to be buildable, that's kind of necessary. So, but I mean, both things is kind of important for me. But anyway, for example, of like one of the facade I designed for Morphosis was Emerson College Los Angeles Center courtyard facade. And then that facade was for the this is actually a dormitory building combined with classroom. So the dormitory building needs a privacy. So this is a screen for the privacy, separating between the dormitory and the courtyard, and that's a public space and for students to kind of have party and barbecue. So I designed this facade to be kind of creative and dynamic and still providing the privacy. But I mean, computationally, that was generated by this type of like certain input and output control. So input was in this case grayscale map, and output is the panel shape and spacing. And then I mean usually go through tons of like schematic design options. Once I set up all the coding setup or coding flow, I just change the parameters and logic, and then generate tons of options to pursue. But in this project, at the end, that technique was replaced at the end by the agent-based kind of particle solver, because we had kind of multiple constraints to solve, like a smoke debug to density differentiation, many things. So, but anyway, that solver over agent kind of gave me to solve the whole thing at the same time. But anyway, but another aspect of like a rationality is that, I mean, we wanted to achieve the smooth dynamic design quality, but we didn't want to have a 3,000 different panel types. So at the end, actually, those panels were unitized into 15 different panels, although half of them flipped. So it's actually 8 different unfolded shapes, which can be nested together tightly to the industry standard 4x8 feet amino sheet, and then specifically sharing the edge of the panel to the next panel to reduce the time to cut the panel by cutting one line to produce that has direct impact to the cost of the production. But anyway, so that's how this type of facade was generated. And other project is the Milan Expo China Pavilion, which happened in 2015. And by architect Studio Linkark, and I designed the roof facade of this building. And the roof facade is made out of a woven bamboo panel mounted on steel frame. And but I joined the project from the competition phase, and then so in competition we kind of rush out the geometry, so that geometry is not necessarily clean, but first I start with a rationalization of the form after we won the competition, and then build a kind of most ideal mathematically or geometrically ideal grid on top of it. And then first I generate like a zero tolerance pure ideal panel first, and then from there, for the construction reality, I approximate all the panel into limited units by like slightly bending panels converted into flat panel, or more bent panel is replaced with like a panel with one fold or two fold, etc. So to reduce our total family of panels. And the another thing to consider for rationality is that we also wanted to unitize that joint, but we can do that, but if we do that too much, that sacrifice the rationality of the panel. So it's kind of trade-off relationship between joint to panel. So that part is needs kind of a adjustment decided by the a stakeholder, in this case client or architect and other areas. So but anyway, so that part is kind of meant so those adjustments to realize that the facade kind of looking smooth, but at the same time you can still pick the certain kind of gap or like a certain kind of deeper shadow, which would be the location the unit of panel is changing. And another example is a hot pot restaurant in China. Architect is Studio Linker and Ken AUD. I designed the facade and the interior ceiling and the wall panels. In this case, like this parametric kind of relationship or mechanism, like a grid is built and then the transform is plus kind of it's creating more kind of differentiation by like a random grids flipping or size change, and but at the same time like a density is control, and then so at the end it's implemented by 10 different panel module to create this ceiling condition. Same techniques apply to the facade as well in kind of elevation, and although the boundary condition make it many things difficult, but we did best to implement them to make the construction efficient. Different type of project I do is a kind of research project. In this case, I try to use a swarm logic, but to build something structure. So in this case, swarm is running, but there's also two more set of agent is running behind the swarm, which is a structure optimization agent. One is for tensile and compressive to realize this instruction structure. So the trajectory of swarm is used for this tensile wire, although that tensile wire was optimized in the simulation to become actually usable tensile structure. And then another type of research is like where I was inspired by those kind of biological mechanism like cell growth. Although there's many different cell growth research and algorithm existing, but I studied kind of a simple primitive one by myself. And then, but in my case, I was mostly interested and focusing topology of those kind of cell connection or cell junction. And like so in this case, in my kind of algorithm, they strictly control, and then all the cell growth is based on that condition of the topological connection, like how many or where to where, and then they all kind of keep track of who is connected to, and which create this. Depends on the what condition activates the cell division. Sometimes it creates the kind of linear growth or kind of branching growth or some kind of collective growth, like a group of cells make the branch together. So that's kind of there's a certain kind of fractal relationship there. But anyway, so that is generated by those controllable mechanism of growth. And then once I try to apply it for some architecture project, in this case, an interior design project, collaborating with an OR project. And then this is kind of lighting installation, kind of slash lighting diffuser slash structure in office cafeteria in office space in China. And but those are kind of the background project. And then one thing, discourse is that in like a past 5-10 years, actually maybe several years to 5 years, so there's a certain kind of discourse about like biomimicry versus artifacts sensibility. So of course, then the part of the discrete discussion. So there's a certain issue like certain first of all, like there's a different quality in those geometrical relationship between the biological form to artifacts relationship. And then at the same time, for example, like the left is my kind of capture of some of my agent-based simulation tutorial. And then I can say they are creating various conditions in terms of density or kind of connectivity or certain type of like flow, but you can still see that kind of not as diverse comparing to the like those classic architecture. And then so that's one thing like this agent-based algorithm cannot achieve. But that, I mean, to me, that is not because it's mimicking biological or nature. And then it's true that agent-based algorithm came from nature as out of observation in complex system science in 1970. But nature is still more complex. So nature also has that kind of like a part to whole relationship, or at least a kind of biological or creatures has that, and so that's totally missing in our like in kind of first generation computational design agent-based system, and that's what I thought. So then more specifically, what I thought missing is a hierarchy in our agent system. Like most of like a behavior is kind of behavior consistent. That consistent behavior creates kind of uniform result, even though that like a density or certain condition can be diversified, but still shares the uniform quality. And so I wanted to bring the hierarchy somehow to the agent-based algorithm. Was I wanted to develop new algorithm. So this issue of top and bottom up, I didn't want to just simply use like a 10 or several different agent-based algorithms. So I could have like a agent type A and B and C, and they kind of merge or collide, etc. That can create that kind of diversified or articulation or hierarchical articulation. But I wanted to maintain those agent like adaptivity of agent-based system, and also the integrity of singular behavior creates whole thing. So one idea I got is the clock. So I wasn't interested. Actually, I was interested in generating like a module, but I wanted to have that module made out of agent. And to do that, I thought of like a body clock of agent. And usually body clock agent in the first generation computer design agent system is a one clock. And then, but what if we have like a hierarchical clock? Meaning, like if the like a bottom level agent has a certain behavior, but the like a second level clock create different behavior. I mean, as example, every second you would do something, but every minute you would do something else, but every hour you would have you want to do something another. So then, so that kind of let me kind of research of the or development this algorithm. So for example, if agent try like a first level is just going straight, but the second level is turning 90 degrees, but the third level is branching out, which creates a sequence of square. But the sequence of square could be turned 90 degrees in the fourth level clock, and then the fourth, when you add the fifth level clock, that could create a sequence of sequence of square, and then you can also, I mean, another level can create like another, I mean, square of a sequence of square, a sequence of square. But anyway, but but still, so this is like a just stacked up behavior. But the one good thing is that you have control. You can insert different behavior in different level. So in this case, the top level turning angle is changed to 30 degree. In this case, like a bottom level straight behavior was slightly changed. So the whole thing as a top level, they are still trying to create a bigger grid, but they cannot because the bottom level agent is not going straight. And then this is just like more kind of steep angle. So only the bottom level agent is turning. The whole other is still trying to turn 90 degrees, or they are thinking making the bigger grid, but they are making something else. So the event, like thinking about the randomness, this example shows a use of randomness in the top level. So you can see the modularity of the lower level is kept. So you see the repetition of like a square of a sequence of square of square. So, but if you have randomized in one level below, like the big module is now kind of randomized in terms of size. And or if you insert in lower, the bottom level square is all kind of not really messed up, but just a size different, randomized. So, but you can still see the whole thing 90 degrees, also quite random. And or but slightly the angle is randomized. In that case, the whole grid start to becoming off. And then, but yeah, another thing, like if the bottom level length is different, the bottom level randomness is randomized. So many randomness happen, then now you start to see this kind of image which doesn't resemble the original grid, but you can still see the mechanism, right? The hierarchical mechanism is same, exact same with the first like all equal grid. So that was the idea. And then so the workshop I did was to kind of explore this algorithmic idea. And this is just an example you can find on YouTube, but specifically the workshop is about this researching this. Then actually we kind of kept it really abstract, so all kind of really abstract geometry, then try to find a mechanism which shows certain kind of richness in terms of like certain consistency and variety the mechanism, but about the hierarchy structure is kind of strong. So in this case, one student tried to explore this kind of a single module, then how it can tie into or like a first more really classical architecture geometry, but towards more biological, although they kind of share exact same hierarchical relationship, and was switching hierarchical relationship a little bit tweaked and they create different type of things, but they share certain logical mechanism. And then another student example is like so one level is kind of distributing the kind of grid in XY plane, but another level is trying to create a kind of three-dimensional cube, and that's so that level also cube has like a 3 or 4 different clock there to create that form as well. But anyway, so those are abstract geometry was kind of result of the workshop, and then but I'm still interested in this kind of keep exploring or keep researching this algorithm, and then kind of try to find more kind of like a good use of that. Thank you very much.
Thank you, Satoru. That was amazing. I'm always delighted to see what you've been up to. I know some of the earlier work with Morphosis, but some of the new work is equally interesting. I should mention also that Tom Main from Morphosis was in a discussion with Wolf Pricks about AI, which is on our video channel. So we get a chance to you can see that also recorded. Satoru, I realize that now it's actually, it's a midnight almost in Japan, or it's just, are you able to stay on for questions or later on, or you do
Yeah.
You are, okay.
Yes,
so let's go through the final 3 presentations. I know there's a question for you already. Anyway, thank you so much, Satoru, and thank you also for teaching a workshop on Digital Futures as well. So we've got 3 more presentations. Sushant Verma will be next, Alessio Erioli, and followed finally by Jan Paneki, and then we'll go into some questions. So let's move on to Sushant, part of the Indian Mafia. We've already had one of the Indian Mafia today, and I have to say that Sushant also, I think, has connections with the AADRL and with Zaha's office and so on. So I'd like to welcome Sushant Verma from RapLab.
Yeah, thank you, Neil. Thanks for the introduction. Yeah, I do have connections, not with the Mafia, but with the AA for sure. I was a graduate of MTech, in fact, not DRL, but I happened to work at Zaha Architects right after that, and moved to LA. I've worked in Los Angeles, and then moved to India to set up a studio over here. So I run a practice here, which is known as RatLab, Research in Architecture and Technology, where we work with a lot of architects and designers to bridge the gap between design and technology. And so I'm just going to very quickly brush through, the kind of works that we are doing and how it kind of leads to what we try to do in the workshop. So as a practice, of course, we're working on multiple scales of projects, right from down to an art installation or a furniture to a facade or even urban scale projects where we are contributing our expertise using computational techniques and tools. We end up creating tools for like stadiums, auditoriums, and various kind of projects essentially. So I'm just going to quickly browse through a glimpse of things right from a smaller scale to something as simple and straightforward as these, where computation is of course used for rationalizing the fabrication, drawing a certain sense of aesthetics to bring in some fluidity through various temporary and permanent installations. This is also one of the prototypes of a facade system which we represented as an exhibition, and moving on to more of interior scale where we are trying to kind of change how spaces are being constructed. And working in India is obviously a challenge because we have to cut down on cost and the fabrication systems are kind of limited. So we typically operate in systems where we are working in combination of high tech and low tech. So any kind of computational tool development or workflow that we develop has to take into account that it would be constructed with low tech systems or less of machines, more of people. So everything has to be kind of rationalized as per that, which is what we do in all of these kind of projects. From lighting installations to, this was a project in Tokyo which we worked on where we were doing this roof structure system which has the form was computationally derived as a tensile form, but with a grid structure. And it was a fairly complex project in terms of how to rationalize the fabrication data vis-a-vis the environmental aspects, structural aspects. This is a facade in New Delhi, India, which we worked on. This is an ongoing project in Hyderabad, where the architects had this vision of something very fluidic, but then we come into the picture as experts to rationalize the facade and stuff, even making it simple for the facade engineers to understand how it's going to be built, and then of course rationalizing the form based on environmental, structural, and geometrical aspects. So of course, computation is used in different methodologies and different types. This is another few facade projects in India, some roof structures, and we are prototyping that on smaller scale. This is a very interesting project ongoing. It's a temple project. So it's kind of a sacred space where the geometry and the sacred number of 11 was very important, which we converted that into a system to create the spatial structure and kind of rationalize one of them to make this large scale temple space. This is pretty much like an aerial view what it looks like. It's a temple in South India. And this is kind of the interiors where light infiltrates in and creates kind of a magical effect which we're trying to do. So the works of the studio of course ranges from even skyscrapers, like this is one of the Hong Kong projects we worked on, where it was more of a sustainability aspects were considered while designing a simple sweeping facade like this. This is again an ongoing one in Delhi, where it's a technological university where we are creating this space enhancer, which kind of protects from the harsh sun and also creates some kind of an aesthetic effect. So this is pretty much, across various scales what we're working on. And this is another facade in India, where we are rationalizing the facade onto 4 kind of modules to kind of reduce down the cost, and developing a facade system with a manufacturing company to kind of come across with a parametric facade, so to say, as a product, as an entity which can be put, and using various kind of combinations, it can be used on the facade. This is another religious projects in a competition we did in Dubai. So yeah, that's pretty much what what our practice focuses on. But I'm here to talk about what we did in the workshop. So we also have an educational entity called Reptile Education, and I have been involved in a number of programs. We do like independent workshops of 2-day workshops, 3-day workshops, and I also run a 6-month program called Smart Labs, which kind of prepares people to kind of go in for their masters into computational design through digital fabrication, interactive design, performative design as various modules. And So, I mean, globally, we've been doing workshops in various countries. There have been quite a few collaborations in the last 5-6 years we've been working on. But coming to digital futures, this is exactly where the challenge came, where we had to kind of reorganize ourselves as a studio, as an academic studio at that time, that how do we impart the knowledge? And I've actually highlighted this in red. This is pretty much what our workshop was for. It was a 4-day workshop, 4 hours per day. So we're literally talking of 16 hours and talking of 60 students who are coming from different parts of the world and having a different kind of background in computational design as well. Of course, we did the shortlisting process, but at the same time, we realized that we have a very large pool of participants coming with different expertise. So how do we, and we are teaching online, of course, a challenge which everybody faced. So how do we rationalize the studio in a very clear-cut brief where everybody can adapt to the tools that we are kind of passing on to people, at the same time make the best use of it and becomes a good learning experience for all. So of course we kind of had to talk about the tools first. At the same time, we have to talk about the experimental nature of the studio. The studio is called the Scalable Tectonic Speculative Futures. So evidently, very clearly, we were talking of how do we speculate future, something which is very, very uncertain. How do we predict something, at the same time get to know how to use these computational tools. Particularly, we were focusing on Grasshopper for this workshop. So we wanted to make sure that we use a good range of tools within the Grasshopper platform, and at the same time allow people to kind of learn how to apply these tools. And a lot of students, like in the last 5 years, we've taught like thousands of students, and what we realized is a lot of people may get a grasp of a tool as a software, but they don't know how to apply that till you have a design problem or an exercise in front of you to work upon. So we obviously gave them a very theoretical understanding of what tectonics is, what exactly we are trying to do in the clusters. The whole idea was to contextualize your projects into a very futuristic setup or a scenario, and use a data-driven approach. And within Grasshopper, we were wanting to explore some very interesting advanced tools, like right from physics engine like Kangaroo and mesh smoothing algorithms from Weaverbird, but also a little more advanced to making recursive algorithms and agent-based simulations, and how to create 3-dimensional field formations and stuff like that. So what we ended up doing was dividing the entire schedule into a manner where we managed to introduce the absolute basics of Grasshopper, to give them a background of computational design, so everybody comes up to a same level. And so they understand data structures and the logics of using Grasshopper, and then slowly moving on to slightly more advanced tools, and then getting onto a design brief and how to kind of visualize that. Uh, there was an understanding, a lot of theoretical discussions that took place in the studio about what tectonics is. Like what exactly is the art of creating something from a physical into a metaphysical world, and how exactly scale matters. A lot of times people get a grasp of the tools, but they don't know how to control those tools. So the idea of the scale was very important. How we can use the scale of a human being, for example, as a representational tool to put your design experimentation into perspective. And of course, when we're talking of future, there's a lot of speculation. So we kind of tone that down into a very crisp kind of a system. So we actually prepared some toolkits, like in terms of like, what are the toolkits? So we had these like 6 toolkits prepared, all of which are a combination of various aspects within Grasshopper. And we started to, expose the students to these toolkits by teaching them all of these tools one by one with a lot of exercises and examples. And then of course we talk about, when we create an object like this, for example, like what do you see here and how do you feel? So we went through a lot of discussions internally within the studio with the 60 people out there, to understand what is their perception when they have a form or a complex geometry or a formation of this kind. just so they get to kind of understand and relate it to a particular scale, like the difference between this and the one that I showed before. And eventually what we ended up doing towards, I would say, the third day, pretty much the third day, that we ended up sorting a very clear-cut system to kind of follow, to kind of automate the entire production process as an output, which would allow people to kind of learn and apply the computational skills which they were learning. So we had these toolkits that we're talking of, and we kind of encourage students to use their own expertise as well, because some of the students came with some advanced skill sets already, but they did not know how to apply them. So to kind of use these kind of toolkits, bring in an environment where you're thinking you're trying to use this and contextualize the entire scenario and use various kind of visualizing tools, and also write an abstract of the story from the future. That what do you speculate in the future? Like, how are you seeing the future? What exactly do you see? So that's where we started to divide people in teams as well. And I'm actually talking about the whole pedagogy of the workshop rather than the output. But coming to the outputs, we realized that people ended up producing some fantastic outputs in a very short span of time itself as well, where once you start to contextualize something in a particular scenario, the whole meaning of that as a space started to change. And that's where the architectural control started to develop within the students and the participants, who again came with different expertise. So I mean, and there were teams which another thing that was interesting as a part of the Digital Futures this workshop was that we had like 60 people. We managed to divide them into teams, and it allowed people to kind of collaborate with each other across different time zones as well, which was also very interesting learning. So it was not only about learning a tool or a software, but more about learning how to collaborate, how to present, and how to actually produce an output in a very short span of time. So, I mean, there were explorations of various scales which people ended up producing using the toolkits. And of course, we had some intermittent discussions and critiques happening to kind of fine tune the projects. And I'm just going to brush through, the various kind of exciting outputs that were produced over this short span of time. This was one of my favorite projects. It was pretty much depicting on a Mars and how the life underwater is. Somebody exploring like skyscrapers, vertical pods. What we realized as an experimentation was that how people, kind of came out of their comfort zones to be able to use the tool, which they already had a very basic hang of before, and position that and contextualize that into a very futuristic setting and scenario. And actually it helped develop a basic architectural skill set as well. So yeah, I mean, these are the various works that people produced based on their creativity and their understanding of the tools. And at the end, of course, we had a like a session where we discussed all the projects. Everybody had a good learning from each other as well. Some groups explored at a smaller scale, some groups explored at a larger scale, some went really crazy in terms of the imagination of what this space could be. Which I feel is an ongoing process. It's a work in progress, I would say, and that actually allowed us to even initiate dialogues even after the workshop, which we are continuing to do with some of the students who are trying to now document this works to take it forward, and how to make it kind of open source and available to anyone who wants to kind of use these kind of toolkits. So yeah, I mean, there's a plethora of works being produced, and that was quite exciting. So now we were working with the students to actually make a book out of this. So which is called The Stories from the Future. So all the works of the participants are now going to be kind of published and documented with the toolkits, which anybody can kind of download and test out. Which I see as a very interesting end result, which is how the workshop has become pretty much open-ended for anyone to kind of try it out and test it out. And so that's pretty much what we did in the 16 hours of workshop on scalable tectonics, speculative futures. Yeah, thank you.
Thanks, Sushan. I never cease to be amazed by the work that you guys managed to get out of such a short workshop. That's pretty astonishing, and I'm also really gratified that the discourse is continuing in some way, and you're kind of establishing, building up upon things. I mean, it's nice to know that we've kind of unleashed something, especially in India, which I wanted to say thank you to Sarita and Diplay, I think his name is. For Young India, who were very instrumental in setting up the India connection. I had a lot of Indian students, we had a lot of Indian students on our workshop, and it's great to know that message is going out there. I kind of suspect that we're going to have an explosion of computational architecture coming out of India. For some reason, Indians
that's dangerous as well.
Computation, it's wonderful to see. So thank you, Susan, and thank you. Thank you to all the students in that group, and I look forward to seeing what else is being produced. Just to say that one of the other ongoing outcomes, of course, this is itself part of the ongoing outcome of Digital Futures World. There's also a Discord channel, which where there's kind of debates going on. If you go to the Digital Futures World website, you can become a member from there. Also, importantly, for next week or next 2 weeks, we're going to be having presentations by students, by Digital Futures, young students on their research on computational design. So this week we have the instructors, and next week, the next 2 weeks, we're going to be having the students. The fact that the deadline for the submission is in fact coming up in 45 minutes. We're going to keep it open for a few more hours. We've actually got some very good and interesting submissions already. But if anyone wants to make a last-minute submission, by all means. I'll make sure that we in the YouTube and the Bilibili chat we get the links for anyone who's interested in making an additional submission. So thank you, Susan. That was super interesting for me personally, and it's great to see this kind of work coming out. So thank you. And I want to apologize for confusing the DRL with the MTech. It's something you should not do. They're very different. MTech was founded by Mike Weinstock, and is very much based on the kind of questions about biological metaphors and performance, initially structures, now increasingly urbanism. But anyway, it's part of that kind of rich discourse of what came out of the
friendship.
Yeah, I mean, I should say that it was started in 2002. MTech, I was there when it was teaching there when it started, and Akim Menges is one of the first tutors on it. So it also has its kind of its own pedigree now, which is really impressive. Anyway, thank you. It was great to see that work, Sushant. I want to call. We now call upon Alessio Erioli, who also years gone. Hi, ciao. Alessio has been part of Digital Futures in the past, and it's always great to see him. He is teaching now at the University of Bologna, but was himself a student of the biodigital course way back when in Barcelona, where I think Matias del Campo helped teach him, and he was a colleague of Andrea Macruz, who's one of our Digital Futures PhD students. So it's kind of interconnected web in some ways. But Alessio, welcome.
Thank you. Thank you, Neil.
Great to see you. Great to see you.
So, okay, without further ado, I'm going to share my presentation. Just a second, because I'm on my iPad. All right. So, are you seeing my presentation?
Yes, good.
Okay, great. So, hi everybody, I am Alessio Erioli. I teach at the University of Bologna. I teach architectural design there, but I'm also the co-founder together with Andrea Graziano and Davide Del Giudice of Codate, Computational Design Italy. We are around since 2009, and we are definitely not, let's say, the standard firm or office. In fact, we don't even have a physical space or physical office. We're a hub of people which are interested into research related to computation and the possible ties to related disciplines, related research lines. And through the years, we've done works that span through product design, collaboration with artists, scientists, biologists, and many more consultancies, and several research lines. For today's presentation, I'm going to focus just on the workshop that I delivered for Digital Futures which was called Architectural Machines. The workshop had the intent of exposing the participants to a particular approach to architectural design, and also be a test bed for some bespoke tools that I was developing and that I'm still refining after the workshop. So on one side, it was the scope was to put the participants in a particular spot where they have to understand how to relate with the potential of computational tools understood in a certain way, and understand which was their choices, their responsibility, which was part of their own initiative, and what was instead part of the let's say algorithmic part to develop, and in doing so trying to tease out specific properties that I'm going now to articulate better. So one of the basic concepts was the concept of machines, of course, but not really physical machines per se, but something that had more to do with algorithms. And this illustration, it's from a treatise on Greek embedded geometry, but it's also inside a wonderful paper by Matteo Pasquinelli, which discusses the rise of computation from material practices. So this was like a ritual to reconstruct the figure of a god, but this god was also made of parts. So the ritual that was passed through generation was actually the algorithm to reconstruct the figure of the god out of the parts. So and basically all of the abstractions that came later into algorithms, all these abstractions originated from initial material practices, and in some realities it's still pretty much so. So like construction techniques are passed on to generations vocally when there is no written tradition or drawing traditions. But also this is also making its way historically into an attention to the algorithm itself, to the process. So we have examples like the Reptile System that John Fraser studied pretty much along its development over the years, and that he presented in its book. Now the title is slipping. I'm sorry about that, but I'm still on kind of a holiday mode. So, but you know which book I'm referring to, and also to the experiments that were more or less in the same period done by Yona Friedman on one side when he was working on his flat writer, which was an algorithm that was supposed to be given to people to design their own flat in the Ville Spatiale, and also the work that was also tied to Yona Friedman's work by the architecture machine group at MIT with Nicolas Negroponte. So the software that you see on the left was actually called Yona, as an homage to Yona Friedman, and on the right you have another software to design urban interventions on an urban scale. What matters to me in the workshop is also that when you use this approach that now it's let's say widely adopted in many schools of architecture, which is reissuing a combinatorial approach made out of parts, components, and assemblages to a certain extent, is also that when you assemble parts together, you also create a sort of an implicit topological connective structure that Yona Friedman was already aware of and was starting to explicit into these diagrams. And this structure of connection is really important because it's one of those invisible structures that regulate the dynamics going on in the spaces that one builds through these assemblages or aggregations in other terms. But I have a specific interest into this implicit topological structure because they are the one that allows you to regulate flow, specifically flow of information. So that is one connection between, let's say, the physical spaces and the abstract structures of the abstract algorithms that generate them. Later on, there are also all the lines of experimentation done by Makoto Sei Watanabe with this induction cities series, which brings the same algorithmic generation and interest for implicit structure more to an urban level. And it all goes to another central concept, which is one of assemblages, which is something that is taken from Deleuze, but it's central into assemblage theory by Delanda. I don't want to waste too many words on this, but just to set the record straight, in the assemblages, the parts, objects and relation coexist, meaning that objects individually have an identity, but they can acquire another more identity or more properties and capacities when they are connected to other objects in the same assemblage. But you can pick one object from an assemblage and translate it into another assemblage, and while the object itself retains its individual identity, it might acquire new identities in the new assemblage. This is something that stays in the middle range of two extremes, one being juxtapositions in which you have just piling of objects without importance to their relations, without the dynamics of communication between objects. Only the individual identity of the object is important, and they can just exist individually. And the organicist metaphor, which is at the opposite end of the spectrum, in which there are no individual identities of the object, they do exist only on relations exist. So in this case, there is a difference when you use parts to do these assemblages between the concept of a unit and the concept of a component, which is something that also Giroud-sen pointed out in a recent lecture, but it's something that is my concern as well for a while. And if you want, you can define a unit as something that is functionally predefined, finalized, and contained. And the typical example that I deliver is of the units in Moshe Safdie Habitat 67, where every unit has already a predefined function. And Habitat 67, despite its groundbreaking nature for the age, it's still a predefined set of spaces, functionally speaking, while the component is something that is more generic in terms of function, is less specified, so it has the possibility to acquire further properties inside an assemblage. So you can generate on a spatial level a more articulated set of conditions, and not just an addition of a defined unit over another defined unit over another defined unit, and so on and so forth. So, given these premises, the last ingredient, I would say, theoretically speaking, to the workshop was the definition of computational space. You will, I hope you will pardon this very, very blunt diagram, and please do not take it too literally. But the idea is that when you deconstruct an algorithm and you go into the real the digital nuts and bolts of it, all you have, and you have another connection to its physical origin, are these logical gates that came from the physical transistors. So no matter how sophisticated or complex is an algorithm, it's always made of those individual parts that basically decide which way or when a flow of information passes in one direction or another. So even though you write an algorithm in a sequence of instructions, when the algorithm is executed, it's actually a spatial distribution of flow. So if you put this into an architectural perspective, each component that you design according to the flow that can or cannot pass through it, or in which direction that the flow can be split, or can be directed. You have components that are elementary units of computation, and the entire object that you produce as an assemblage can be used to compute as well, because then you can trace through the topological structure that it's implied when you build it, when you generate it actually. You can trace the flow of information, and you can add the parameters that simulate the capacity of each node to transmit the information, or to split the information, to distribute the information into its to its connected components or not. So you have let's say a pretty interesting metaphor here for how to understand assemblages. So you have assemblages of spatial computing components that regulate the flow of information and they form this complex nonlinear network. So one of the aims of the workshop was to, and actually one of the current aim of the toolset that I was testing for the workshop, and then it's still in development, is to not to just to generate assemblages of components, but also to be able to navigate, to explore, and use the assemblages that are generated as a computing structures, and then compute information through those structures. For the space and for the time span and the scope of the workshop, this was not always possible for all the projects, because with the participants, I wasn't too strict into imposing this view. It was presented to them at the beginning, but then I gave them enough leeway, also because I wanted to test how much the tool set and the bespoke approach could be stretched through scales, through several cases. So in some cases, this attention to the spatial qualities of computation was not entirely met by the project, but I was okay with it. I preferred to see what kind of output could be done, or which were the difficulties in using a certain approach, where were the bottlenecks or the difficulties of understanding of certain specific terminology or specific steps. So the basic approach is designing components that were sufficiently generic and have a sort of a wrapping geometry to control, for instance, coherence of collisions together, and doing connection by means of these handles that are, let's say, just joints. So you have a handle-to-handle connection, and then you can assemble parts. So there are several parts in which the designer has his or her say into the whole workflow. One of it is, which is very important and it's critical, it's designing the component geometry and designing the components connectivity. So you have a lot of say design freedom, but you have a very, very wide territory that in which a lot of direction lead you to dead ends or cul-de-sacs. And the other was to design actually the heuristics, the syntax for which, let's say, telling the system which part goes where, which handle connects to what other handles. So the system has also a method of automatically generating, once you design the components in your set, the system will automatically generate all the possible combinations. So you have a visual feedback on what happens on the basic interaction of components. So you can even manually call or pick the ones that are not of your interest, or you don't consider them viable. And so all these systems of designing geometry, designing rules of engagement, and designing syntax is also can also be controlled by external information, such as scalar fields or vector fields for the orientation of components. And some of the participants actually use this. The intention was to give the system a lot more decisional capabilities. So when you assign, or when you have to decide which is the next element that you need to add to the assemblage, you basically ideally never use a random assignation, but you always use something that is derived from some criteria at work. So instead of randomness, have some distributed decision through the system. This was not always possible with the workshop, but it's one thing that it's definitely a goal for the final development of the tool. So here are the works that that were developed during the workshop. The workshop was like 5 days, 6 hours per day, more or less. The last day was presentation, so it was, and the first 2 days were tutorials. So they had like 2.5 days to develop their design. This group, Jan and Alexandra, started with developing the contrast between two very different scales. One that was the larger scale was based on the definition of a scaffold, and you see that the heuristic that they were using given the set of connection that they designed. And they started to control how the scaffold was developing according to these two simple geometries. And then they started to use the scaffold using the shortest path algorithm. So they could query the topological structure of their assemblage. This is based on the A-star algorithm to determine some path. And inside those paths, they decided to insert in the component involved in this path a high-res geometry, which was based on these tubular elements on 2 different scales. So they were able to control the growth and also control the growth direction. So this is the logic of responding to a vector field in the environment, and the vector field could be generated by a polyline, like in these cases. So, and they developed their design and they decided which was the scale. So there was this very, very wide range of scales, from the very big to the very small, increasing resolution, creating I think a very interesting interesting visuals for sure. So another group, Prasadi and Andrea, Saurabh and Andrea, sorry, they went like full urban. So they consider the impact of some urban visions, like Plan Voisin, this was translated in New York, and also Super Studio, Continuous Monument. And they decided to make something for Manhattan as well. So they picked an entire strip in crossing the Manhattan Island, and they just work with a containing volume, again an internal polyline that was controlling the local direction of the involved component, and then they used a couple of components and also some elements that were assigned into post-production, which means using the actual assemblage as a structure that could be queried, and when certain conditions were met, the post-production element was placed. So again, they scanned the possibilities, the table of aggregations of the components. The X's are because the combination of handles was producing an incoherent geometry. So there were like compenetrations or impossibilities, geometrically speaking. So these are actually automatically called from the table. And then some choices about direction, about the volume, were derived from let's say top-down consideration. So they put their own design agenda into it. And these are some of the visuals from the unit. Another research, another project by Alia and Nora was focusing more on voids, on how, despite we build through elements, the spaces that we live or the spaces that are involved in an architecture are mostly voids, and showing how, for instance, in the Salk Institute, you don't have just voids for people, but voids also for a considerable amount of void also for technical HVAC and all that part of architecture that is mostly invisible. Or a page taken from Christopher Alexander to highlight the role of void. And then they decided that they wanted to work with something that had to do with a constructed element, but also considering its containment as one element that was involved into the assemblage process. So they produced the heuristics table, selected the heuristics the heuristics that they preferred, and then started working in developing the assemblage and testing a bit of the results, and also trying to make sense of the possible circulation patterns or flow patterns, let's say information flow, but also circulation flow for people in this case. And you have a visual of the project from the inside. Actually, I opened the workshop to 10 participants, but only 9 showed up. So Wei worked on her own, and she had a very interesting set of references from this Babylonian labyrinth to Monument Valley. There was definitely a very interesting mood board here. Unfortunately, for several reasons, she had some difficulties and she had to work alone. So her project didn't produce the same amount of visuals that the others did. But nonetheless, she came across something quite interesting, because in the beginning she started with elements that are taken from scanning the components. So one of the elements was definitely a stair, because in all of the reference, the stair is central. But also the interesting thing came out when she, let's say, turned up the notch a bit on the abstraction of the stair. So the stair became less of a stair and more of an abstract addition of blocks. And so it started producing some more generic qualities that worked both in the orientation as a stair and also in other orientations. So diminishing the definition in favor of more abstraction and losing specificity actually worked better for the project, even if in this small outfit. And lastly, Alberto and Shermin, they decided to work starting from 2D patterns and specifically understanding that how they could reproduce by carefully selecting the heuristics. For example, the behavior of the Langton ant when it starts getting into an highway. So after a while, the algorithm of the Langton ant produces this long highway, so to speak, this linear evolution of the pattern. So they started from designing the wrong component, trying to apply it to a 3-dimensional result. And by selecting the heuristics, they were able to use this as an organizational feature of their output. So they try to be maybe a lot more in control of things than other outputs in there. And given this the function, let's say, or the putting it in as an orbiting space station. So yeah, that was it. Let me go.
Great, Alessio, thank you. I never cease to be astonished by the kind of imagination and the hard work that went into these workshops. That was fantastic. Great to see. We just want another comment about the submissions for computational design that are due in today. We're leaving it open for a while. We have some like 700 people viewing this on Bilibili. and I know that Jane, Jen has put her connection there. Unfortunately, Billy doesn't allow you to put the whole, enough characters to put the whole link in for the submission for computational design, but her contacts are there. YouTube, I think we already have that as well. So, Alessio, thank you so much. Grazie mille. So finally, our final presentation today, Jan Paneki, who I first met about 4 years ago. I think he set up an event in Paris where Benaz Farahi was there, and also Daniel Bolojan. And Daniel, of course, has been central to the whole of Digital Futures world. So Jan, it's great to see you again. Whereabouts are you now?
I'm in Slovakia, Bratislava.
Right. That's one of the wonderful things. We connect literally the whole globe at this particular moment. It's a bit inconvenient for some people, and now it's getting late for Satoru. But anyway, Jan, please, over to you. How do I pronounce your? By the way, how do I pronounce your research group? Do I call it research or ResiArc or ResiArc?
Yeah, this is something I wasn't really thinking about when I established that. I thought it's a really nice wordplay, and I never actually realized that it's going to be difficult to pronounce. So it depends. When I'm speaking internationally, I call it research. Here at home, I do it phonetically, which sounds something like ResiArc, but I think research would be fine.
Okay, great. Over to you then, Jack.
I'm also very honored that you remember our encounter. It was a wonderful event in Paris, and you gave a fantastic speech, and then we had a debate somewhere out in a park, which was also very fulfilling for me.
What I would say is that I think what comes out of all these things, that the people that you meet then become way more famous, and the students that you inspire. I think you act as a catalyst for just opening up all this realm of ideas. So anyway, thank you, Jan. Over to you.
Yeah, and also because you mentioned that, it's a really good start of what I'm going to talk about today. My part of the Digital Futures was slightly different from the other impressive things that we saw already. And I will start a little bit broader. About 10 years ago, I started. I really wished to be more involved in the theory of architecture, and I've never had the opportunity. So I created the opportunity myself somehow, and I established what you mentioned. It's a platform called Research, which is I will show the links later on when I share my screen. And the platform first started here in Slovakia, which is in the center of Europe, only 1 hour from Vienna, but still it's considered to be somehow part of the Eastern Europe. And the architectural environment here is a little bit less experimental and forward-looking. Anyway, so I started here, and this was mainly because I wanted to meet people who could inspire myself and somehow teach me what I was lacking. So I started organizing all sorts of debates, conferences, meetings. And in the first year, which was in 2009 or 10, we organized about 16 meetings like this. Public meetings, and then I started somehow lecturing myself, and I had several attempts to write some sort of a theory, which very soon was obvious that it has to be the theory of computational design. And I'm not really these things were important mainly for me to organize my own thoughts, and while I could disseminate those thoughts, I always took the opportunity. And this was happening for quite some time. And very soon I started teaching courses at local and European universities, mainly courses teaching tooling. So it was mainly about Grasshopper and programming and processing and so on. Also, we organized a lot of workshops with invited guests. Alessio was one of them several times, which I'm very proud of. And then I also started teaching. And although I also was teaching a studio at a university, there was always this sort of a struggle for me that either there was not enough room to teach tooling, or there was not enough room to teach concepts behind, at least for me. Also, meanwhile, like 6 years ago, I established an online platform where I'm offering online tutorials for Grasshopper, and not only me, but also invited tutors. And we've got a lot of content there. But at the same time, over there, it's still mainly the tooling, not that much of concept teaching. So I've been thinking, even before the pandemic was around, that there is something that I could do about this struggle of mine. And maybe there could be a new form of online or even offline teaching that would not really compete with the existing ones. Like, it wouldn't compete with tutorials, it wouldn't compete with the university teaching, but it would be complementary somehow. So I came up with this structure that very soon is going to happen as a reality under a new brand called ArcSays. And it will be somehow revolving around some agenda or a person. So it will be a curated content where people will learn not only the tooling, not only the concepts, but also all the things around these things. So the idea is to create some sort of courses that will be either online or offline, but basically they will start with some sort of informal introduction of a person or the agenda that will be the backbone of the whole course, which will be some sort of an interview, a person talking to another person in a human language, explaining what is all the agenda about. Then we could have a couple of theoretical lectures or theoretical presentations about the background of the architectural creations. Or the creative process, and then in the next step, the person, the carrier of the agenda, could show how these concepts are actually applied in the practice. How did they actually embody in the architecture itself, and eventually there should be the tooling tutorial as well, basically showing how to achieve all these things. There's a lot of tutorials like that online, have been recently, mainly through the pandemics, showing how to achieve something that a famous architect has been doing. And I think it's okay, but when it's not authorized, it's always just mimicking the outputs, not really going into the depth of what the architecture is about. And in my idea, it's very important to understand why somebody decided to do things those ways. And also then you can also learn the tooling and how to get the skills to achieve something like that. So when this was kind of almost developed in my mind, and already some courses have been planned, I was approached by Daniel, who kindly asked me to take part in the Digital Futures, which was a huge honor for me, and I agreed. I thought I saw this as an opportunity to actually test this concept. And because it was a short notice, I didn't really have all the famous and talented guests set up. So I decided that I will try to guide my students, my participants through the topics that I can help them with. And when I was thinking about that, I came up with actually 7 distinct topics that I could talk about and explain in this structure, which was a nice coincidence because there were 7 days that I could take. And at this point, I would like to share my screen, and I will show what was the lineup of my workshop at the Digital Futures, which was called 7 Short Stories of Computational Design. Then I changed the name to 6 Short Stories of Computational Design. I will explain very soon why. So every day I had the same structure. Every day was about something different. The first day was about computational design. And at the beginning, we started with an interview, basically a debate between me and Eva Bushakova, who was basically trying to understand why am I interested in computational design. So it's kind of a cheeky thing to do, but I was the guest of the first day. Then I gave a lecture that I was giving a couple of times already when I'm sorting my understanding of the computational design, what it is. So after the short interview, we had the lecture, and then there was the hands-on part where I was showing how these things can be actually applied, and I was showing my past projects where I'm somehow actually, I don't know if you can still hear me or see me, because something goes strange with my Zoom. All good? Okay.
Yes, we
sorry,
can.
sorry. Sorry for the interruption. So anyway, I was trying to demonstrate on my own project how the concept of the computational design could become part of certain projects. This is also kind of complicated because the oldest project that I was showing was from 2005, when there was no Grasshopper around, and I'm also showing how can you actually apply these concepts without knowing the tooling, because at that time I didn't know the tooling. And at the very end, there was the tutorial part where I was actually showing people, like giving the proper Grasshopper tutorials to the spectators. And in the first day, I was showing my own plugin called Boyd, which is a swarming simulation plugin for Grasshopper Anemone and all sort of iterative design. The next day, I was talking about research, the platform that you also mentioned, which I didn't really want to go that much into details, but also I can show the presentation that I was showing at that time. But again, there was a short interview at the very beginning, a lecture where I was explaining what I think are the best practices for teaching and learning tutorials, mainly the ones that that I was giving. And then I was talking about research Grasshopper sessions, which I will show very soon. But even before, I would like to show you what did it look like 10 years ago when I first started organizing debates locally. And we gathered a group of people and we were debating architecture. And this is something that I was talking about in the morning of the second day. And I was doing that mainly because this was something that was very inspiring for me, something that also brought a lot of new ideas and thoughts. And I was trying to encourage people to actually do the same, showing all sorts of activities that we had throughout the time. This is actually the event where you were taking part as well. So let's go to back to this. I was also showing the tutorials that I have online, which is here, and I can show this. This is not actually advertising, because this is something that will disappear very soon, because we are moving to the new form, the new platform. So this is not going to be available anymore. But I was explaining how the content was divided and split, and how to actually understand the topics of the computational design when it comes to the tooling. And the plan here was that for the tutorial part, I was planning to talk about why don't I like using plugins in Grasshopper, which is a very specific thing. I call it vanilla with sprinkles on top. And when I was talking about that, advertising that part, Mike Pryor approached me, who is a friend of mine, and he made probably the largest plugin for Grasshopper called Pufferfish. And he told me that he's really looking forward to see what am I going to talk about. And we decided not to do the tutorial. Instead, I called him and we had a chat for 2 hours, and we were debating all sorts of topics of the computational design and tooling. Which again brings me back to the idea that all sorts of networking and meeting people and debating is very important, because it brought up new things. Also because he was watching one of my videos before. That was a nice surprise, something that I wasn't planning up front. The day 3 was called Unusual Suspects. And as I told you, I'm currently in Bratislava, Slovakia. I'm at our studio here. And the place is really close to Vienna, and Vienna is one of the melting pots of the computational design and contemporary architecture. And it's not really happening here, and nobody would actually expect to come something extraordinary from this location. I've been striving to do that for a couple of years. Although not really advertising where am I located, but still doing everything from here. But I invited for the day 3 people who are in this area, so former Czechoslovakia, Slovakia now, and Czech Republic, who are actually teaching very interesting stuff at the universities. So we had guests from 3 universities. One is Umprum from Prague, from Czech Republic, where I'm currently doing my PhD. And the guests were Shota Cekolia and Imro Vaško, who are actually having a studio there. Then Jiří Vítek from Brno, Czech Republic, the second biggest city in Czech Republic, who is having a studio over there. And Martin Uhrík and Roman Heitmanek from Technical University in Bratislava, who are having data lab, and they were actually showing what they are doing. And then at the end, they were giving tutorials on what they are teaching at their university. At the very beginning, we had a debate as well. They were explaining their concepts. And for me, this was, I knew that they were doing really good stuff on a very unexpected condition. But I was very impressed by what they were showing and how contemporary they can be technologically, and also when it comes to the content. The fourth day was an ArcSACE day, which is the new brand that we are hopefully starting soon, that will finally bring this format of teaching online. And at the beginning, there was a presentation of what ArcSACE is with Eva Blšáková and Lucia Monitorisová, who are actually the managers of the new brand. And then we had a very short, condensed version of a course like that with Manuel Jimenez Garcia from Nagami and Lucille Bartlett. Who was, we had an interview at the beginning, then he gave actually 2 theoretical lectures. One was more theoretical, one was more sort of a presentation of what they are doing. And then I was teaching a tutorial based on his guidance. So eventually the audience got the tutorial that was showing how to achieve what Manuel is doing, but it was authorized. He was there with me and he actually was approving or correcting whatever I was talking about that tutorial. The next day was called Subdigital Day. Subdigital is our studio, our practice, which I will show here a website. It's sub.digital. If you're interested, we are trying to apply the computational design into commercial work, which on the website looks like we are making presentation objects mainly, but in fact, we need to update the website. We are doing a lot of design as well, using parametric tools and digital fabrication. So on the day 5, I was talking to Tomáš Told, who is my associate, and Anna Čefová, who used to work with us last year. We had a debate about what subdigital is and what does it mean to do computational design in an environment where the clients don't really care that much about the content. And then we were showing how we were somehow hiding the computational design and parametric design into our commercial projects. And at the end, we gave a couple of tutorials, again, showing how did we achieve something that we did in practice. And as I said, I decided to make it a little bit shorter. Actually, no. On the day 5, there was one new thing that happened. When I was talking to Mike Pryor, I was approached by Anouk Wipprecht, who is an amazing fashion designer and fashion tech artist. And I've been following her work for years, and we never spoke because I never really had a good excuse to approach her. And eventually she approached me and she said that she liked the debate that I had with Mike Pryor, and she offered to also make or she agreed to make an interview when I was asking her things. So eventually on day 5, we made an interview with Anouk Wipprecht talking about the computational design in fashion, which was amazing. On day 6, day 6 was slightly different because we mostly use Grasshopper as the tool for what we are doing, but under the hood, we very often use different tools, different programming languages as well. So the day 6 was completely about programming software development beyond using Grasshopper. And we were showing software that we developed in our studio for designers that has nothing to do with Grasshopper, but is using the concepts of the computational design. The guests of this day were Jan Todd, who is our in-house programmer, who is a genius in software architecture teacher, and Lucia Dubacheva, who is a promoter of the contemporary design, contemporary new media art. And I still want to show you this site from the Digital Futures. The idea was that the 7th day was dedicated to robotics. We do have a robot available here, but because this was in the middle of the pandemics, we didn't. The robot wasn't really accessible for us. We couldn't go to the place where the robot is assembled. So I decided to skip the 7th day. But eventually, because the debates were so interesting, I decided to add one more day, and on the 7th day, I made 5 short calls to friends of mine or people with whom I would like to talk to, and I called I called Peter Busch, who was actually mentioned in one of the previous presentations. I called Francesco Cingolani from Paris, who is leading Volumes, which is a place where we held the conference twice. Then I called. Then I called. I'm sorry. Chris Miller from Vienna, who is having a studio called Bewegende Architektur. And then I called Ryan Vincent Manning in the US, who was so kind to get up at 5 a.m. To talk to me. And also I forgot about Mateusz Wierzicki, who is a friend of mine, and he's made all the super important plugins for Grasshopper. And I'm showing you this because you can find all the videos, everything that I was talking about here on YouTube. We recorded everything and published and edited, and everything is available. And you can access those videos from the link here on my Digital Futures page. Here it's still called live stream, but you can see the playlist here. It's more than 30 hours of videos with a lot of guests, a lot of interesting content that the guests brought to the debate. And also most of these things are shared on the Facebook of Subdigital, which is our studio or practice. Also on research, which is the educational platform that we are having, and also on my personal Facebook page, where you can find most of the videos as well. That's all from my side. Hopefully I wasn't too long and boring.
Thanks, Sharon. That was great. So let's move straight on to the questions. The reason why I say this is another Satoru. It's very late in Tokyo right now. And I know that there's a question from Marina. So maybe I can invite Marina to ask that question to Satoru. Marina?
Yes. Hi, everyone. I'm Marina from Argentina. Thanks for all these inspiring and generous presentations. The question is related to the idea of facade and hierarchical agents behavior exposed by Satoru, but also can open a conversation with Bishu and Sushant, who refers to facade as well. And I think that Satoru and Sushant presentations are related in a way in this concept. So as far as I see, we still are in the surface of computational design. And we need to go deeper, and I want to open up some concepts. Therefore, I mean, I would like to talk more about about envelopes, maybe, than facades. I don't think that the last invisible layer of envelope is not relevant, but it's part of a multi-layer space. It has an in-between where the assemblage can define and regulate the exchange of energy, data, flow, information, and the reversible and interactive contact with the environment and the affection also with humans and non-humans can say that in a way the envelopes can define boundaries and interactions with context. Because of this reason, I believe that the scale and proximity define the involving processes in the projection of the dynamics in time, which wasn't mentioned, and particularly consider, for example, Alessio presentation in the conception that, in a way, this great and local differentiation in each part of a component as an individual can create a global impact or an effect. It is also a political action and a conception in which any part is important, and in their association in a bigger and complex assemblage can be a dynamic and an adaptative in terms of energy and potency as well. So to what I would like to ask is not the idea of facade attached to a traditional and static view of architecture. Consequently, is not the idea of envelope more accurate for this kind of design?
Okay, so okay, should I start? All right. So, but anyway, it was quite a broad question kind of topic, and then, but first of all, like I understand like a concept of envelope versus facade, and I mean maybe envelope could be like really expanded to the room, to the building, to the whole architecture, so that could be seamless. But first of all, like a building, constructed building. That's one thing. What actually we can see, analyze, etc. But the process to build is various. Many architects have different way, or facade design have different way. Then, but the analysis is another thing. Like analyzing the aspect, and you focus on the environment performance, one thing, and the emotional performance is another thing, and the meaning like both ways, multiple kind of there's no single way to approach this, but we each has our way to do. And for example, in my case, like in the time during the time I was designing the facade in the past, yeah, I was detaching the facade as a surface, and then the building is building. That was mostly came from especially when I was in Morphosis, because that was the kind of human workflow as well. Because there's a domain, and there's a project designer, and there's me. So that was already detached. Also, we have conversation, but kind of we each have the expert kind of skills, and we try to relate, but still different. But for example, that kind of frustration, like that kind of frustration separation was kind of forced me to develop the algorithm I was talking in the presentation. And then that was my own way to approach how I could integrate that separated entity. For example, so I was still interested in emergence, even if that is a old topic. So because I still think that could one of the key things of agent base, that was still one way to approach agent base, is that the unpredictability. Unpredictability would either cause chaos or something amazing which we never seen. So that quality is something that kind of design opportunities that I'm searching through agent base. Yeah, I try to have that not limited only surface or only 2D drawing to the building. So that was the idea of the hierarchical approach I took. Well, it's still super infant and super primitive, but for example, one of the students in the workshop start building like a roof single panel. So that just one agent tried to make panel, but as the next hierarchy, they create like a surface of panel, and then the next they start to kind of fold into, so that became like a single has a behavior becoming a roof, and then next that can become wall, and the next that wall can be connected to has a space, and then that could be stuck up with the house or a building or whatever. So that hierarchy was kind of that continuous hierarchy. So no unlimited stackable hierarchy out of one agent I was interested. So that was my approach to integrate that relationship. So then, of course, at that, but one thing is that I'm not really that point calculating the structural integrity or environmental performance or like emotional like quality that could be integrated somehow. I don't know how, but somehow, but that wasn't the initial idea. But that could be some key to integrate, or that would be just some other factor to control the parameter. But I mean, some other architect or some other computation design would start from emotional response or environmental performance, but that was my way. Then I believe other designer has different way to start. So that's my response.
Maybe? Yeah, go on, Maya.
No, come on. You can continue.
maybe to pick up with what Arturo mentioned, and also this idea of facade versus envelope, and maybe if we somehow not necessarily compare, but put the work of the firm Morphosis and the fascinating work done by Arturo next to the work that, for instance, we should present. Can we say if the computation starts earlier in the design process, we can somehow expect integration of computational design in a more, let's say, rigorous way, comparing to the cases when we start computation quite late in the stage, quite late in the design process, and then this results into maybe having computation merely applied into the facade. But at the same time, this is one question that maybe we can sort of address. Is the computation is it about like computing the physicality of what we are going to produce, or is it also something that maybe somehow Alessio also mentioned in his presentation, basically computing the hidden structure of the space, right? So where we are not necessarily computing the physical instances, but maybe configurations. So maybe Vishu or Arturo can maybe reflect on that.
Like he currently believes that the computation should be all the different performance aspects, such as if it is environmental performance or thermal heat, like people moving in and things related to geometry like structure, fabrication, all of these things, because with the current tool sets which is going around and accessible to a lot of people, it should be included in early stage design. It doesn't need to be, that's one thing which we kind of always look forward to, is at initial design stages, the algorithm doesn't need to be like super accurate. It doesn't need to be 100% accurate, but even if it is doing 80% of the job, it's already informing the design in a better way. You can always optimize it better in the later stages of design, but it's always important to consider all the different performance aspects at an early stage and try to embed them in your design procedures or design workflows. So you're already in the ballpark or in a constrained design space, exploring it under the constraints, whatever the constraints might be. It'll be different for each individual designer. But for us, those parameters are structure, fabrication, environmental performance, and more so, like more people, the office, there is another research group which is getting into how people move around in this space, or the influence of people movement, how it informs the geometry is also an important aspect which we are looking at now.
Thanks, Vishu. We actually have a question from Antonio coming up, but before I open the floor to Antonio, could I just say, if anyone has a question to ask, could they put it in the chat channel of either Bilibili or YouTube, and we can get someone to relay it to us. In Bilibili, it's got to be a very short question. Okay, Antonio, over to you.
Yeah, thanks, Neil. Thanks, everyone, for the very interesting presentations. And perhaps I wanted maybe to pick up some suggestions from Alessio's interesting presentation to propose a quite general reflection in connection to the previous session. The previous sessions were on artificial intelligence, and now we've moved to computational design. So I found very evocative, the analogy that Alessio introduced at the beginning of his presentation of the rules of disposition for ritualistic purpose, no? And he used the expression that the ritual was the algorithm, no? So later on, you have explained that in algorithmic thinking, no matter how, you said, no matter how sophisticated an algorithm is, it goes down to somehow a flow of information through logical operations, no? And this somehow highlights the, if you want, intelligible, rule-based nature of algorithms, which inherently, I think, is quite different from the black box nature of many artificial intelligence processes widely discussed in the previous sessions, you know, machine learning, generative adversarial network, and so on and so forth. So somehow a quite overarching question could be that maybe for Alessio to start. So how important it is for you the intelligibility of the functioning system, of the process in the system, both in learning and also in professional environment?
Okay, that's a great question, actually, Antonio. Thank you for it. I think there is a nature of the profession of the designer or the architect or whoever does the project that comes into question, which has to do with, on one side, the specificity of things, and on the other side, the scale of the output. This is an analogy that also Nicholas Negroponte does in the architecture machine with the analogy of the beach, like the scale of the grain of sand being the specificity, the scale of the entire beach being the complexity of the outcome. So whoever does a project always moves in a dimension which is in between, which means it cannot deal with the extreme specificity of things. So it will have to make compromises at some point. And on the other hand, it cannot handle alone the complexity of an entire project. So it has to offload this complexity to different entities, whether they are persons, whether they are artificial intelligences, but it's definitely a core process that takes place there. So I'm definitely interested into the role of artificial intelligence, especially not in the obvious sense of the engineering application, the reductive application to optimize things or to make like learn a task and do it better than humans. This is of course very useful, but that's not my focus. I'm more interested into seeing what these algorithms or these processes and these ways of approaching things can deliver if they are applied to an open-ended process. So maybe Neil remembers the AI Young presentation where Alessandro, a student of mine, presented his thesis project. That's actually the very first result of this line of research, line of interest, which is actually couples with what I presented before, which is when you have to, when you decompose the the design process into a series of choices, because in the end, what you do is you or somebody or something performs a series of distributed choices. What if you put an artificial intelligence to perform these choices at some point in the process? And if the process is not a specific top-down process, but it's an iterative process where these decisions are distributed, you're not deciding something on the global scale. You're not deciding how to generate a cat, for instance, but you're distributing a huge amount of microscopic choices throughout the process. What would be the product of this kind of thing? And then you might have also other kinds of artificial intelligence that help you, or they do it autonomously to make sense of the landscape of things that you can generate, because then on the other side of it is the incredible amount, the sheer enormous production of generated outputs that you have when you use generative algorithms in general. So the other side of the generative is like the overload of production that you have to sift through when you search for a design option, unless you want the entire cornucopia of production, but that's not usually the case, especially when you tie to the profession. In the profession, in the end, you have to come up with a single option that then goes through the construction process, through the realization, end realization.
Actually, that's quite interesting take on machine learning and use of artificial intelligence. Yeah, I kind of agree on that, like I always see artificial intelligence or machine as in a multi-layer setup, one with the human. So they do tasks which the human are not able to do. They kind of and help in constraining the design problem or exploring the design in a constrained space, which instead of exploring a plethora of options, you're already limiting it into a constraint set, which the machine would be able to help in doing. Or I always think of it as an augmentation of intelligence than machine taking all the decisions. So it's always like a multi-game player setup where human is one of the player and machine doing a specific task is another player. So it could be related to sun, orienting to the sun, or it could be related to other aspects or performance aspects, but very specific tasks can be given to the machine, but still the human has to be one of the players.
If I can,
go on, please.
I wanted to just continue this trend of like, the way I see this discussion is how the relationship of computational design with practice. And I want to ask you, Alessio, I was a very happy coincidence, actually. I was going through the same literature that you mentioned early on in your presentation a few months ago. And I wanted to ask you the same question that troubled me when I went through the work that was done early 60s with Alexander up to like a bit before the 80s, I guess, with Iona and Urban 5. And what they tried to do almost 50 years ago, it was to make a sort of mixed initiative design system, maybe generative or not, that almost anyone could use, right? And they had some techniques that even today, if I sift through the most, let's say, recent papers, we're still trying these techniques out, right? So my question was, and it's not very easy, why do you think 60 years later, maybe this for the whole panel, why are we still not able to develop something like that in practice? So why isn't what they were trying to do in the 60s and 70s, and it seemed very clear what they wanted to do, like exactly what some companies or even practitioners try to do today. Why can we not make it work in a way? This is kind of my open question.
The answer is exceedingly long and complex for this format. I think I can definitely suggest a reading though that I finished recently. It was one of the lucky pick of the summer reading, which is Last Futures by Douglas Murphy. It's a very interesting book that actually does scans through the history of the avant-gardes of this from the post-World War II to the 1980s, 1990s. And there are also listed some of the reasons, but one of the main reasons I can think of and I can list on one side is that I think we evolved with a more sophisticated model for reality, which includes complexity, the idea of complexity and emergence that was at the very beginning at the times, but it was managed still with the mentality of the modern, with the mentality of sort of still there was planning behind it. And the architecture machine, Negroponte, was one of the first attempts to do this thing iteratively, but it was still, I think it was still not ripe enough to stick. But this happens with a lot of things that are invented in unsuspected times, and they are in a way too far away from the context, and they do not have the chance to root. And maybe later on, you grow up the premises in the society, in politics, in economics. Thank you, Neil. That was the book. And then the same idea now has more fertile terrain and has the opportunity to, in an evolved form, of course, not in the same specific format, has more chances to attach and grow, to root into the common sense and be more widely accepted.
So just to say, that book that Alessio mentioned, Last Futures, Douglas Murphy.
Yeah.
Great. Maybe to pick up on this idea of reality versus what we do in research and academia, when I was looking into the work of Digital Future workshop by ZHA, I was also connecting the results to what, for instance, Jean Prouvé did in his modular house and this idea of prefabrication. So when we see the results of that work by Prouvé, you see there is a certain level of simplification versus maybe rationalization. And can we, for instance, say what we do in academia and research might not necessarily be the, we might not necessarily search for a one-to-one translation of what we do in research and academia. And in practice, things may sort of evolve and co-evolve differently. So maybe Alessio or Vishu can comment on that. How do we jump from this really provocative and interesting research to practice is an interesting question.
Yeah, it's always like a question we keep asking ourselves as well. Like generally, the trend has been like what there is always a time for research to gestate. It takes at least 3 to 5 years of research on it for it to gestate and then move into actual practice in an office. So things we were researching maybe 5 years ago is now, as I was mentioning in the presentation, now starting to bear fruit in terms of architectural geometry getting applied into multiple scales of projects like a stadium, residential offices. So these were things which have been developed. The technology also had to be developed, right? So these things are not all the algorithms and things you need to learn first. Everyone has to learn it in first principles and know it, and then only you can come up with design ideas based on these tools. So it takes a while for research to gestate. It's always good that so you can. That's why you need to do some technological demonstrators to actually push the envelope. To say, give an idea, okay, this is possible, and then comes the optimization or making it more cost effective or making it build faster. These things come at a later stage, but you need to take a leap of faith, and generally there is a time frame for these things to happen, and that's from my experience. At least it's been about 3 to 5 years.
Also, I mean, to extend and take it from there, what Vishu is saying, I kind of very much agree, and we face a very similar situation, here as well. And you're talking of the gestation period of a research, like 3 to 5 years. In practice, the gestation period or acceptance of any kind of new technology or new tools is actually like 10 times more than that, unfortunately, So there's always a lag between the practice and academia. And, I'm giving a few examples from the facade projects, which, we started the discussion on as well. Every time we're doing a facade project, we end up creating some new tools or workflows, which we think is going to be beneficial for the next project. And you get the next project, you try to use the previous tools, or you change your path and trajectory and then develop a new tool. And it keeps on happening, like you keep creating version 1.0, 2.0, 3.0. While at the same time, I mean, the acceptance level of a particular project in reality is much more slower. And, by the time the project is built, especially in architecture, which will take a few years to build, the tools have already advanced so much. So that is also a challenge that always is there. And facade is one thing which is, I think, one of the favorite canvases for computational designers, because that's where you can express a lot of ideas and test a lot of tools. But at the same time, a building envelope or a facade, I think, is one of the most complex and challenging aspects of architecture as well, because you don't have to, I mean, on one end, as an architect, you're trying to bring a sense of aesthetic and a sense of experiential value through an envelope. At the same time, you have the challenges of the environmental aspects, the rationalization of, let's say, visibility, and the fabrication aspect, the cost, materiality. It is fairly challenging, which usually people don't see. I mean, you only see, okay,
Yeah.
there's a cool design, to look at. So people think, okay, you can just design something using a tool. So I found that, I think it's also to do with the kind of technologies that are available. Like in our projects, for example, I mentioned there has to be a blend of high tech and low tech always, because working in India specifically, I know that the technologies in construction, the kind of finesse in construction is not there. So your tools have to keep adapting towards that. Whereas at the same time, positioned globally in terms of the academic, circle, we find ourselves in a very difficult situation, because we're trying to create tools for the practice, which are I won't say which are as sophisticated as it should be, but that's how we are trending in the academic front. So there is definitely a gap. Which we always kind of face between the both.
Yes, and in fact, my question wasn't directed to differentiate the idea of facade of envelope. It was more related to understand the complexity and how we as practitioners and architects who are building, I mean, if we can decide the multiple layers that we have and the space between, and that's what I was talking about, the boundaries. And I think is very important what you said about the context, for example, because you design like different pieces, but you don't know if you are going to, where these pieces are going to come from, and if you can fabricate it in the country where you are doing your building, for example. So there is a lot of, this is what I mean with assemblages, that there is a complexity in this, just in this world, that to call them facade, maybe it could be an academic research to think about how are we going to call this element, which is not only an element because it's not like a static thing. It's something that it requires exchange of energy, all these assumptions that we mentioned recently. So I think that maybe this is one interaction which is important, to redefine the concept, or to redefine how we call things, to make this complement with the practice, and to rethink the practice as well, to make it to push it further in a way.
The boundary, actually, yeah, I'm really kind of intrigued with that like, thinking about the boundary, especially I used to work in Morphosis, which has, less boundary between me to Tomei or like a whole architecture team and all other engineer, but now I'm independent, so I'm outside of architect, and I need to work with architect and I have to work with the client. So that makes it difficult, which is kind of true. But at the same time, that makes it clear that who I have to convince, or how I have to convince, or what I need to do to make that building happen. And then so like thinking about like building construction efficiency, the performance, there's a certain kind of already conventional aspect you can sell, but who you are selling, that's the question. Plus, most of us, like architects, as a computational designer, we also pursue certain design advancement, design vocabulary, new design, etc. That would sell to you, to architecture community, but that wouldn't sell to the client or stakeholder. So we kind of need to think about the stakeholder of that. Each project is different, but as is architect or computation designer, if we find certain benefit out of our design technique or design quality out of your production, we have to clarify what benefits to the stakeholder. Meaning, yeah, environment performance, yes, and then structure, of course, and then cost, yes. But if that is a commercial project, and you want more, if you find that you kind of want to think about the does the sales goes up if you choose your design, or if it is at a school, does that make the students learning more efficient? And if that is office space, if we can quantify like happiness of the occupants somehow in the future, if we can quantify that and sell that to the stakeholder, I mean, then our kind of design can be sold. And then meaning we have to communicate, we have to translate the benefit of our design to, I mean, for stakeholder or any kind of people working together or interfacing. So that kind of a translation or like a quantification would be something I feel like getting more important. So currently, a performance like as a facade designer, I always do this like a performance analysis and then like a cost efficiency. That is already kind of conventional. People or even clients can understand that part, but we might need to invent more representation, more way to sell our design, which wouldn't be any kind of pure post analysis thing, but that should be also core idea of our kind of design initial concept. So, but anyway, so that kind of effort to inform other people or project members to the client, etc., that is very important for us, I guess.
Can I just chip in there? I was actually I was struck by Vishu's comment that it takes 5 years for ideas that are going on in the Zaha Code research group to actually filter their way into practice. Actually, something very similar happens in theory. You know, you read a book by Foucault or something. You can't just apply Foucault to architecture. Somehow you've got to let it absorb, you know, into your way of thinking. You have to plant a seed for something, and it comes out years later. But there's an interesting kind of question that comes up, particularly with this panel, in terms of the two different, let's say, discourses of architecture. Stanford Anderson talks about the discipline of architecture, which is essentially what goes on in academia. And he contrasts that with the kind of the practice, the profession of architecture, which has very different constraints. I mean, I think what's interesting, and particularly about the Zaha Code group, is the fact that somehow Patrick finds a way of, out of the kind of the budget, as it were, from the office, of investing enough in that kind of research that eventually kind of feeds back into the practice itself. But I think one of I think the Zaha office is particularly interesting because of the kind of the synergy that goes on between the kind of teaching and the practice itself. In fact, actually, when you hear Patrick talking, he kind of moves seamlessly from what he's teaching in the DRL to what the offices are doing in a very interesting kind of way. And I think that in some ways, to have that possibility of reflecting an academic environment and bouncing ideas around is a way of kind of somehow feeding into practice. At the same time, it's good to have the practice to kind of to make the academic work somehow in a way relevant. But I do think that maybe I could ask Vishu about that particular kind of tension of how do you manage to operate in a commercial office with a research group, which is, I mean, it's kind of interesting because you've got the DRL, the Design Research Laboratory, happening in the school, and then you've got the Zaha Code Research Group happening in the office, and this kind of interface.
Yeah, I think that's like the interface is kind of very important for us, be it at the DRL or at the UCL over the last couple of years to we actually initiate research ideas in these academic setups to test and understand new technologies. And then when we feel that things are gestated enough in an academic setup and there are pilot projects in the office which we can try out, then that's when we introduce them into commercial projects in the office. So that's what I meant. It takes time. So 5 years includes this ideation in an academic setup, and then putting it forward as a pilot project in the office, and then it becomes a transfer of workflows to much more bigger projects. So this timeline is what I was talking about. And yeah, so it's an interesting, like I would say, because Patrick also is quite, he believes in academic research being part of commercial setup, and then how the both feed into each other. That dialogue is quite important for most of us. And yeah, that's the, like what we try to push on both ends, try to see, and then try to meet somewhere in the middle to see. Yeah, it's not always possible to do research only on commercial projects. So that's where, yeah, Zaha has invested in creating, doing some kind of technological demonstrators or pilot projects where you experiment with or take a leap of faith to see if things work, and things pay off sometimes, and sometimes they don't.
I also, if I may, I also think it's kind of important to understand into what world you're proposing your design. I think it's kind of natural that over time, it again became the value system that is out there with the clients and with the commercial practice. It involves terms like simplicity and purity and intelligibility and all these things that probably are not in our vocabulary really. And when we are working with the computational design, we are striving for complexity, which is a complete opposite, or some sort of control over determinism in very strange conditions and emergence and all these things and stuff. The computational design does right now is it actually performs really well in the values that we've set up for ourselves, but this is still not out there. And if we want to somehow push it to the real world, first we need to change the vocabulary or the narrative that we have to actually speak with the contemporary narrative, which has a different value set. And then if we do it consistently and long enough, we can probably change the vocabulary and change that those expectations that are changing from the simplicity to complexity and so on. But for the moment, I think this is not really only a matter of how difficult it is to convince somebody to do something, but also how do we say that? And if we use the right terms, which is always a problem, if we use the right terms, then it is possible to actually bring this to the practice in real time in quite a short period of time. And I think that we all struggle with this communication with, doesn't matter if they are clients or conventional architects or our peers. Very often we use the wrong words because in their value system, what we are proposing is not a positive value.
Right. Sorry, Neil. Yeah, I just wanted to jump in really quickly because I think this is really interesting. This leads me to a question that I've been asking myself. First of all, I'm Victoria. Sorry, I didn't introduce myself. And the idea that I have is, what is going to happen in a time where actually things and technologies like quantum computing are pushing into the technical environment. And we as architects are kind of challenged with this idea of speed and optimization on the one hand, that is kind of pushing in, and that goes along with the rationalization and therefore maybe even a flattening of the built environment, just as, applying it as tools of optimization. And as architects, how can we, as creative thinkers that are kind of connected to a complex system, where even irresolution and unexpected outcomes are influencing our ideas, and that is kind of the core of human thinking for me. And how do we see our responsibility to kind of educate the public? I mean, we've kind of been talking about this, but how do we hold back and find these kinds of spaces to kind of push back? And what kind of education do you think we need to, come up with that can help people kind of balance that very, very difficult balance between, on one hand, optimization that goes along with speed and also quantum computing, and on the other hand, our complexity of thinking and the kind of playfulness that we have. What do you guys think?
I was just going to mention that one of the comments was passed on to me by someone who'd been working in the Zaha office, but also been part of the AA setup, was that the way Patrick operates is a very different kind of language. Just pick up on the term of language that Victoria was mentioning. That in a way, the academic debate, it's a much more kind of theoretical debate and more nuanced in a certain sort of way. But in the office, it just becomes, well, that's cool, or something kind of, you kind of short circuit things. And I think that's very interesting to way of approaching things. But I'm not so sure whether we have a role to educate the public. That's the kind of, that is one of the kind of the challenges in some way. You know, all the thinking that goes on behind a building, in the end, it's the building itself, and the client, or the public sees it as it is. So there's definitely two different discourses in operation: the academic discourse and the professional discourse. Does anyone pick up on that?
I think on what Victoria mentioned about the speed and optimization, and how perhaps the way we can move forward is not by scaling up into, I don't know, larger design spaces and more complex projects, but maybe by outreaching like to the vast majority of the projects out there that really computational design doesn't touch, which is small scale, low cost, some informal projects that most of them don't even have an architect on board, right? So this is what Susan was mentioning, and it kind of fascinates me, this idea of like high tech and low tech. Like that should be a very good teaching experience or like learning experience on how can we take computational design to these projects which have no access to things like this, like even like not just simple massing, but also like, you know, performance studies and all the things we take for granted. So perhaps this is how we can kind of scale things, kind of like vertically, in a way, like outreaching to
touching on Neil's point and also Victoria's thing is to we don't have to educate the public, agree on that, but we should include the stakeholders make them participatory in the design process, and they have their own feedback, and all the stakeholders will have. And that's something we are striving for, to get them as early as possible. And that also brings into things like technology transfer. Like when you're working in contexts like India or Latin America, like you need to first build something and transfer the technology onto the locals. And countries like India and Latin America are very susceptible to this. They are eager to do this, I think. And because most of the workshops we did, all the like 10-day workshops in India where we tried to build something, they were very eager to pick it up. There was no technology available. So we had to adapt the computational tool sets to that specific as what is feasible in India or in Mexico. But they all were eager to learn from it. And I'm sure like Sushant can support this, that there's a lot of interest in computational design in these kind of upcoming countries like India and Latin America. And like even the first pilot project for this kind of participatory configurator kind of projects which we presented is actually in Honduras. So there is people who are interested in it, and it happens to be in Latin America and in India.
Yeah, I think sorry.
Okay.
Okay, so just taking the what cues from there, what Vishu is saying. Yeah, I mean, I totally have experienced that, you know, fully, that people in India and like other countries which are susceptible to, you know, these kind of technological change, they love that kind of a thing. But at the same time, I would say there is a lot of you know, there is a lot of gap between the learning and practice, you know, because of which people want to learn computational design, people want to see the change happen, but at the same time, we are not very fully invested into learning. The education system is not changing at a good pace. At the same time, people want shortcuts a lot of times. That's what I've observed in, you know, last 5-6 years of you know, being an educator in India, that they want to learn, they want to adapt, but we need to also realize that we need to go an extra mile to adapt the tool to the kind of low-tech systems that we have. So that requires an extra kind of effort. And a lot of times, majority is looking for kind of shortcuts and use these tools to create, to make them go from point A to B without understanding what's between, you know. So, I mean, those are like issues we deal with. So I don't know, like how your experiences when you did workshops in India was, because I last workshop I did in London in January this year, and then I had a workshop immediately after that in India, and you see the difference between how someone is learning the same technology or a technique and in a different manner and applying that in a different manner. I see a lot of possibilities and challenges both in that kind of a scenario. How is it in other countries or other places?
Anyway, just okay. No, I can wait.
Okay, no, just I want to just throw in something there. That is the fact that I mean, I think the tension between the kind of the academic discipline and the profession is a really interesting one. But one of the things that I think that where I mean, the profession is hugely important in all sorts of ways. But one of the real challenges I think is in terms of the profession is the way, whereas in academia, I mean, we have become kind of universal. I mean, this platform is itself an example of a kind of a completely global platform for debate. You know, English has been adopted as a language, and we are connecting throughout the world, provided the right time of the day. But the real challenge in the profession, in a sense, is it's hidebound. It's constrained in many ways by some of the structures that are in place. I mean, I find it interesting when I've had some letters from the Zaha office, and there's always at the bottom of the email letter saying, you know, for the purposes of, and then you give a definition of the architect, because what you get is actually still these kind of structures in place, especially in the States, where you're only qualified to practice in one particular state, and you have to somehow, you know, qualify another state. Meanwhile, you know, someone like Zaha is completely universal, international, and you get this kind of real tension sort of building up in terms of how you operate internationally when the kind of professional structures are also local in a way.
Yeah, I just want to add one thing to Bishop's comment about this kind of optimization of adaptation now in the digital process to build in certain countries. And as I remember this Greg Lynn show when was Patrick Schumacher, and Greg Lynn asking to Patrick about how they build. I think it was one building in Georgia, and Patrick's answer was that they imported. They have to develop like supplies to build it. So they import the material from a German company, and other time from a Danish company, because they couldn't build it in the place. So if you are, I mean, if now the decision is to try to adapt the design to the techniques that you're able to have in a country, I think it's great. And I think that this is maybe the interaction between academy and practice, because we have a lot of critical thought in academics in the last years. Even I remember one article that Sarah Polo wrote about the political envelope, when he states that he was criticized in Princeton because the construction of architecture during the 90s, and he had to give an answer in that way. So I think academic is important to give a critical point of view about how we build. And also, I think that that's why my question was related with facade and envelope, because I think there is a lot of political question. I think Sarah Polo made the correct question, even if he's not studying these things right now. But this always, I mean, also this distance between the office of architecture, the office when you produce architecture, and the building process is a distance as well. I mean, this idea of optimizations sometimes is criticized by the reality of the construction. So we have these incredible ideas. I think they're incredible ideas, have robots building on the street or all the things, but then you don't see it on the street, you don't see it in the reality. So I think this is important, because I think that there is a necessary feedback between academy and practice, and between how you think a building in your office and how you build it in the reality. So I think this kind of feedback is what we need. That's why I think that's why I'm here, at least, and that's why I want to share my I don't know if it's my knowledge, but my ideas of my point of view with you.
Yeah, I agree with that. Like, but also another role of what academia can do is to bring forth this kind of collaborative attitude. Like even in India, like it's very normal now in institutes in the Europe and in China for architectural institutes to have a robot. But in India, it might be that robot might be in an engineering department. And that is the tie academia has to bring forward, that they need to do the collaboration, that you need to bring an attitude to architectural teaching, that you can collaborate with someone like an engineer or someone who's doing into thermal optimization. So there are this opening up of doors, and that can be done by academia, I think, and that is very important, that to develop that collaborative network to understand where things are. So even if you want for example, a laser cutter won't be available in some institutes in India. It would be available in an industrial sector in Bangalore or in any big city at the industrial sector or area will have this, but you need to know where to find it, and that know-how academia can bring about, I think.
Very interesting. I wanna maybe continue with what Marina mentioned about this connection between academia and practice. I want to also borrow from what Satoru was mentioning about the way, for instance, he became a kind of a independent consultant in the recent years. So this somehow also brings us to this topic of how we can define and teach the social and economical aspect of computation in a way, right? So I'm not necessarily saying that we need to think of a business model for that, but maybe institutions like like platforms like Digital Future or what, for instance, to a certain extent, Jan was trying to address in his talk, can somehow bridge this gap between academia and practice with an emphasis on the way the social and economical aspect of computation can be taught and can be basically flourished. Maybe Jan, you want to pick up on that. How do you think that these social and economical and political aspects of computation can be sort of taught and explored?
This has been a struggle, at least for me, for quite some time. The thing is that we do believe in the computational design and we do believe in what we are doing, and somehow we don't really need to convince ourselves. And also, I personally don't need a motivation to actually do something like that, because I believe in that, and it gives, it offers the answers for my own personal questions. But then it doesn't really very often it doesn't really make much sense to anybody with whom I'm speaking who is outside of the bubble. And from a broader, again, from a bigger picture here in the studio for the summer regime, we decided to start some sort of an internship program. We gathered a group of students, and they together with us, they are conducting a research project, and we are developing new tooling, but also we are developing new narratives for the tooling, and also the way how to disseminate the ideas behind the tooling that we are developing. And we are pretty far in the tool part. So the tool already exists and it does things, but we are still struggling with the narratives. We don't really have the words to say about that. And it's a constant struggle, but we did our due diligence. We investigated on what other people are saying when they are promoting their projects. And they're very often very experimental and avant-garde, which also means if they are avant-garde, that means that they are not contemporary, they are futuristic. And so what other people are doing is that they are actually talking about their projects as solutions to existing problems. Although very often I see personally that it's not the real motivation for those projects. And I think it's okay. But if you offer a narrative, if you offer a story that what you are doing is actually bringing a solution to an existing problem to which people can relate to, then it's much easier to communicate the project. And I believe that in reality, what is happening is that this is not the only thing that the project is doing. You actually do a whole package. Whatever you are doing is way more complex than what you are saying about that thing. And it seems to me that you currently need to use the existing words, the existing questions and problems, and give answers to something that people already know, and very slowly hide the new things into that, not only in the content that you provide, but also in the words that you bring. And you need to do it in a very balanced way. And also, I agree completely with Neil that we don't really need to educate the general public. I think we need to educate ourselves to properly communicate what we are doing. And in fact, I still believe in some sort of idealism. We don't really need to always bring solutions to existing problems. Sometimes we can just be just charmed by whatever we have available and whatever we can do. I think it's perfectly fair to do things that way, in a selfish way. But then when we are talking about that, I think it's important to somehow bring, point out things that matter to other people now. And also one last remark, what I've noticed, the most publicly successful and well-known projects that we looked into, when people are talking about them, about the projects, they never describe the project itself. They always only talk about the story behind, and the story is always what is the problem and what is the solution of the problem on a general level, not really describing this looks like that and it performs that way, but generally describing what the solution might be. And I think that's the way to proceed.
Yeah, I just want to say that, I mean, I guess we're all involved in academia and teaching in some ways, and we tend to privilege that and say this is where ideas germinate and eventually filter their way into practice. But there's also another way of thinking about things, and that to say is, what can academia learn from practice, despite the kind of the financial constraints of practice? And I think it's important that, because if you think about it, I think it was firms like Gehry Technologies or Frank Gehry opening up that and bringing computation into the world of practice, because he had to. The only way he could get his complex buildings built was by using these tools. So, and you compare that to some academics, you still get places where there's some guy who was, did a PhD on Le Corbusier 40 years ago and is still teaching Le Corbusier, completely out of touch with things. And the other thing I think is kind of interesting in some ways, to go back to kind of Victoria's point about, educate the public. In some ways, I think the biggest kind of, the moment that we as architects are probably most proud of in some sense was the Bauhaus, and this moment of kind of this incredible generation of new ideas and so on. But actually the Bauhaus failed. The Bauhaus failed largely because the public didn't really get it. They didn't really want it either. And it was probably too expensive, whatever they were doing. And I think by comparison, IKEA has worked, because the public, I don't think they care too much about design, frankly. At least talking personally, my sister, she doesn't care about design. But if it's cheaper in IKEA, she will go there. And I think IKEA is kind of the genius of IKEA is actually be able to produce something that actually is well designed, but producing in a way that becomes accessible to the public, and the public will go for it. So I think there are two sides to this coin, and I think that academia can really learn from practice in many ways.
Yes, and also.
Oh, sorry.
Okay, no, just one thing. And also academia has two important things. One is the idea of experimentation, and the other is the idea of critique. So we have both sides in academia. I really don't believe in the professionalization of education. I think that academia is a place when you have to experiment. Do experiments with your designs, but what I believe is this critical side, this place for critique is important to open the boxes and to show the process as well, to be reinvented in a way, to be rethinking in a way. So that's why I believe that we have these two ways in academia, the critical and the experimental as well.
But couldn't you say, I mean, it's kind of interesting because I was thinking about the GAN, you know, the generator and the discriminator, yeah. but it works both ways. I think, you know, I think that also there's a criticality that comes from practice sometimes that we overlook in academia.
Yeah, of course. There is this feedback that I was talking about. I mean, and there is a lot of theories, which it didn't start with a previous theory. It's the theory that you build after make some designs and to build it. There is, I mean, that's why I'm interested. That's why I'm a teacher, I'm a researcher, and I'm a practitioner as well. I build my buildings as well because I believe that I want to understand all the complexity of what we do as architects. It's not only to do only one thing, but that's my point of view in that way. So it's personal.
Yeah, one thing I want to go back. Like I just want to point out one benefit of computation in general is that when Neil mentioned about the Gary technology, that not necessary that you can see that as an optimization tool, I mean more engineering oriented tool, but you can also see that is a communication tool between Crown Gary to fabricator. That's communication because they couldn't communicate, they built that tool. So in the same way, we can be, our design tool is also communication tool. And it's currently most of our design tool is for us and for the colleague and academia or architecture discourse, but that we can build a tool for general, for fabricator, for stakeholder. That's what we can do. Then currently we are cultivating the Zoom whole education platform. We architects could be, I mean, I'm not proposing building another Zoom, but we can design something computationally to kind of disperse our knowledge. Because we are tool builder, we can do that as well. We can design that. That's not only architecture, but it's for society as well. So that's kind of one of the strengths. Our, I mean, computational design, our computation kind of skill people. So yeah, I just wanted that part.
I'm just thinking, this has been a fantastic debate, but in some ways, and it's been a debate about bringing, I think, practice and academia together, and then seeing the differences. One of the things I think we've done in this platform is bring the whole world together, but also seeing the differences in terms of time zones. And I'm acutely aware for Satoru, it must be about 1 o'clock in the morning or later right now in Tokyo. So we should maybe kind of try and wrap things up. Let Satoru get a bed. But maybe
I'm fine, by the way.
You're fine. Okay. All right. Well, let's carry on. I don't know if anyone has any other pressing questions to raise.
Well, if I may put a few words in for this, I mean, there is a healthy distance between academia and practice, which means it's a distance that creates this kind of interaction, like mutual traction and repulsion. So one pushes the other in one direction mutually. So, but I'm talking about the healthy distance, which is not too short and not too far away. You have to find a sort of a sweet spot because academia has a role and profession has another, of course. There should be communication, but not complete merging or complete coincidence, because otherwise you risk a few undesired effects. And I think there are a few things that I wanted to go back to the discourse about IKEA. Like, first of all, there are a few great design from IKEA. It's just that the designer are not the famous few that go into magazines, but a bit of anonymous ones. I mean, I remember the case that an Italian designer, Achille Castiglioni, designed one of the most widespread light switches ever, which is a very simple light switch that went in all of the houses. There was a period in which a famous designer designed everyday objects, like the Mocha. I have a Mocha by Marco Zanussi, which is, and I think that it's related to actually part of the narrative and the topics that the courses at the academia are touching. Right now, I've seen it also in the B-Pro presentations, the super crits that took place in the past weeks. There is a return also to the topic of housing. There is a massive return to that topic. Before that, I remember all the outputs from the DRL, from many other universities. The main topic was a museum, was something that was a much more, let's say, one-of-a-kind type of architectural design, which means it doesn't make it any less important or any less experimental. But the contact of this type of design with what is the common sense or the common feeling about design is quite different. So like there is this, I think it's a myth, of course, but there is this common perception that architecture, okay, if you want to do architecture, you just call the architect to make the grandiose project, which has a role. I don't dismiss the role of catalyzer, of polarizer in the urban fabric, but there's also the role of an architecture that it's, let's say, less of a catalyzer, more of deciding the flow of everyday life, intervening in how you shape your daily rituals, because the spaces also have the power to influence that. And I think that same thing with everyday objects. They shouldn't be dismissed. There was also a period in which a lot of famous architects and designers went on designing everyday objects for the houses, like carpets, tapestry, curtains, sets of dishes and tableware. I don't remember the name of the current, but there was a beautiful exhibition at the Centre Pompidou a couple of years ago about that. So it's also about where the things are directed. And I don't think that things should be directed one or the other way. Just that there should be more heterogeneity all around.
I think that was a great point to have. There needs to be a certain distance between these two discourses. Actually, coincidentally, that is exactly the comment that Mark Cousins at the AA made many years ago about the relationship between theory and design. There needs to be a kind of distance in order to kind of abstraction and so on. No, I totally agree. I was just thinking when you were talking about the popularity, I was thinking of the figure of Hani Rashid versus his brother Karim Rashid, because Karim Rashid is very famous for designing a bin, a rubbish bin that's everywhere, and yet his brother does this one-off kind of in particular buildings. Now that's a. Do we have some sort of final questions? Other questions? Okay, well, this has been a really, I think, what often happens actually in this situation is that the discussions afterwards, the work was great that was presented, and I was really, I think it was fantastic to see not only the workshop, but also see what you guys are all involved in yourselves in terms of design and so on. But the discussion itself was also extremely stimulating in a way, and I hope that we can gradually, we're building up this profile of this. We had something like 700 people on Bilibili in China, and that's one thing that actually we kind of the failure in some ways is that we can't, because of the firewall in China, we can't use YouTube in China. So we have two different communities being broadcast separate, the same thing on different platforms. But it's great to see this gradually building up. I just want to say one final comment about next week. We're going to have some sessions by the students. So again, it's been fantastic what we've had so far, the submissions, and we'll keep on computational design. We're going to leave open for submissions the platform for a few more hours. We've already got some really good ones, but just to leave it open for anyone at the last moment. And then we'll continue on from that. We're planning to do robotic fabrication after the computational design things. I'm hoping that next time round I can hand on to the next team, just in terms of kind of like, I feel like I said my thing. I want to hear what the new generation has to offer, the new Digital Futures Young Committee. But I just want to thank our speakers today for two things. One, for contributing in such a selfless way. It was amazing the kind of the response that we got to the call to arms, as it were, that we put out for Digital Futures Young, to go and give for the instructors to give their time for free to bring these ideas to people throughout the world who otherwise would never have had access to them. And I think, the appreciation I've had from students has been astonishing. I just want to thank you, the instructors. It was really a fabulous act, and it's been amazing. And you never know quite what. I would just say one thing, one thought. You never know quite what's going to happen when you float an idea out in front of an audience. I've had two particular people that I know whose career was completely changed by just something I said at some point about something in a lecture, including Daniel Bolojan. I was in Romania and I said something, and suddenly that sparked something, and now we have this amazing, one of the great AI designers in the world coming out of that. So who knows what you've done, and you're in part. I just want to thank you for that, because that's really important. I'm particularly glad that we've got two our contributors today are from India, because that's one area that I think we hopefully will have more of an impact bringing these ideas to India and elsewhere in the world. But it's fantastic. And secondly, thank you for these contributions today. I think this is really great. If you're not aware, these are things that have been uploaded onto YouTube. We're gradually building up a huge library of different talks and discussions and things. And what's interesting about those also is they have an afterlife. In other words, you know, there are a number of people who are watching, but then we can track how many people watch the video afterwards. So, so thank you, everybody. I look forward to next week to the student contributions on computational design. And let's not forget that we are all students, right? I mean, we're all students. So thank you guys so much, and for both, for the workshops and also for your contributions today. So see you next week, same time. We'll be on with some students presenting computational designs. Thank you, guys.
Yeah. Thank you, Neil,
Thank you
and
very
thank
much.
you to all the organizers.
Yeah.
Cheers.
Thank you.
Thank you. Thank you.